Okay, it looks like it's going live. Let's see if there's anybody in chat that can test it. Oh, I'm ready for the action. This is a beautiful board. Hi, everyone. Okay. Hello, everyone. We're probably going to be waiting another minute or two for people to kind of fill in. But this is going to be probably the second to last CH32V003 USB live stream. We're getting very close to everything working. Right now, we don't have any sending data back to the PC working, but I was able to compile all of ESP8260 ESP USB for this machine, and so for the C code. So we're really close to having everything actually work. I'm glad to see people are definitely starting to pile in. Is all of the audio okay? Can you hear me clearly? And maybe if you guys want to, like, you would have to speak up, but say something.
Hello. Hi. Hello.
Can you guys in chat hear them? Audio is great from the one. And for them, what about them?
Hello.
Audio is working. Okay, that's good. Okay, so I actually have not tried running this since we've last talked, so I'm going to have to make sure that we are at least where we were when we left off last time. So let's do that now. Okay. So I have, let's get the chat up here. You could increase the volume for everybody. I can increase the volume for everyone. Yes, give me a minute. If I can find the knob. Okay, this should be up for everybody. Do you guys want to say hello again?
Hello. Hi.
Is that clear? MM is cool? Let's plug in. Oh no, it is not currently working. Okay, let's see what that looks like if I zoom out. All right, actually that's pretty good. Yes, so we're exactly in the same place we were last time, which is where the host system tries to send a USB message to the chip, and then the USB chip apparently, I'm guessing, wants to respond, but instead of responding, it just locks the lines in low mode. So that's totally, or I guess low and high. It just locks the lines in default mode. So we're gonna have to go fix that. And yeah, it looks like Friday got a reboot up and running. Does Tony Stark know this? Does Friday? I don't know if I get the joke, DIY. Although Friday the cat is right here. See him? Right there. The cat cam, though, has been replaced by people cams, so. Okay, so stream 4, we are going to have to debug the back stream USB. Okay, and then, oh, I shouldn't move that there. Okay. One of the things, I guess I should point out, who was it that was working on the OS X CH32V003 fun stuff? Did you get an invite link yet, somehow?
Yeah, I got it.
Okay, so that's in the CH32V003 fun channel. If you can just post the problem, there's like a couple people on OS X, so.
Okay, cool.
Friday is the OS for Tony Stark. Is it? I didn't know that. So I have a cat that's, anyway. Oh, I don't know if you guys know, it's Friday the cat is his name, so that was the joke. Okay, so RV03 USB-S. So just to recap, what we did over the last few live streams was we wrote this file here, which can read in USB, and then we started writing the stuff that would reply to USB, so that's down here. And so we're going to have to debug it. So all we know right now is that when we want to send a reply by USB, something happens, and then the lines get locked, and then that's just it. The chip is just stuck in la-la land for forever, and nothing works. So we're going to have to resolve that. And actually, it's even worse. You can see right here where the host USB is like trying to drive the USB, and this chip is just like clamping it down on it. So that's just not working. Yeah, I'm not really sure what's going on there, but we're gonna hopefully figure that out. Actually, if anything, that almost looks like it could be. Oh, I don't know. I don't know. That is very strange. What I'm seeing is behavior where it's like the line is kept at 2.6 volts somehow. Not really sure what's going on there. Yeah. But we can see some of the replies from the host trying to get through, and they're just not able to get through because the chip is clamping it. Are you up and running yet?
No, not yet.
Okay. So we should try to figure that out. I guess the first thing that we should probably try to do is just set the pin states, send something, and then go back off bus. So what we're going to do first... Oh, more people are talking. Looney got to play some with your SDK last week during the stream. There were some issues with having a massive amount of MCUs connected to the programmer, though. A massive amount of... Oh, BitLooney got to use the SDK. Excellent. I'm really curious what those problems that BitLooney ran into are. That would be interesting to know. Also, BitLooney, if you watch this, please just like tell me about your problems instead of just like having them. I would love to fix your problems. Okay. So what we do first is we're going to set up the GPIO base. Then we're going to, what does this do? This looks like a 1 is going to configure DM to high and DP to low. And then we load that in the BSHR. So let's see. So DM would be high and DP is low. Is that what we're seeing? So DM is high and DP is low. So that is what we're actually seeing. Let's see, does that make sense? Yes. So that would be right here is where that event is happening. So with USB, what you have. Wait a minute. What is this? Okay, this is sus. This is super sus. So with USB, you have a thing where it's called a single-ended 0. So you have the bits coming along. And oh, by the way, if you want to see like what I'm looking at on the scope, you can pull it up on YouTube. I don't know if this is... Okay. But with USB, you have bits coming along, and then if both lines are low at the same time, it's called a single-ended 0. And what that indicates is that's the end of the USB packet. Although here it's like it flips around. I think that Looney mentioned something about USB low speed being flipped. So maybe that's what we're seeing here is that flip. And then it changes state. So what I guess I want to do is I think I want to what is S1 here? So I load S1. And I AND it with S3. And what that does is it's going to clear out USB DM and USB DP. And then I work back together and I store it. So I guess what I could do is I could return from the function here. How do we return? I guess that's this code here. Done sending data. Yeah, let's do that. Let's just go in, jump to done sending data, and then go back out. So what this will do is it converts the line to be push-pull so that we can push the lines high and low right here. And then down here, we're done sending. Let's comment this out for right now. And let's see, does this make sense? So we're going to load word into S1 of the CFGLR. And we want to clear the lower 2 bits here and the lower 2 bits here, but that's not right. Okay, time to look at the data sheet. Where is it? Downloads? It's the downloads folder. I think that code is wrong. So CFG-LR, this is organized where each one of the ports takes up 4 bits. So this has got to be wrong if we're altering CFG-LR. Let's try that. This should be 4. Question?
Yeah, I'm just not really trying to get it set up to get working.
What are you running into right now?
Just like where to start.
Can you check the wiki? I think that one of the people who've been working on this project has been working on a wiki article.
Oh, okay.
Let's see, not Wikipedia, but like the wiki on GitHub.
Yeah.
I would have set up.
Okay, cool.
Let me switch show yeah. This one again.
Did you use the wiki article or did you use the steps for installation?
Yeah, just.
Oh, did you use the wiki article or?
I used the GitHub README.
Okay, I would try the wiki article. It has a little section for Mac OS X.
Okay, cool.
It does say to use risc-v toolchain with homebrew following these instructions. And it does have a brew install. So hopefully that's along the lines of what you're after.
Yeah.
We should probably I'm gonna open that issue. We should probably actually make the wiki the thing that points to instead of
Yeah, I downloaded this.
remove
Yeah, I did this
parts
one.
of README in favor of wiki. So
If you go back.
making a new issue
go
there.
Oh yeah.
Open it up and then go to like, beginning. And then just open it down.
Okay, so now what we're doing here is we're gonna clear the bottom 2 bits
Type.
of
Okay,
this, so there'll be 0, 0. And that's input mode, so that's good. And then what else do? We OR it with 0, 1 for the top 2. Hello, Omar. And then 0, 1 for the top 2 is universal output. Oh, input. Floating input mode is what we want, so that's 0, 1. Okay.
Type me.
I think this code as it stands now is correct. So let's go flash it and see what happens. Shoot, I should have been prepared. Okay, let's see if we're still clamping the line, because I really hope we're not clamping the line anymore. What's going on? Okay, so we are definitely not clamping the line anymore. That's really good. Let's see here. So you go to a single-ended 0, something happens, something else happens, and then the line is in like some sort of random state. It was vague read error while trying to write the thing. It's much too early. What time it is for him to wake up, but try tagging him on his Discord. Okay. Yeah, I don't know what the problem is, but if we can resolve that over the next bit, I would love to make the programmers able to program like 128 or 256 of these things in parallel. That would be a lot of fun to support. So what's going on here? It looks like our lines are kind of noodling around some. I think the default behavior, so let's see. Yeah, it looks like this is D plus and D minus really are backwards. Hey Friday. You're a good boy. Say hi Friday. Good boy. Yeah, you're a good boy. He's a good boy. Okay. I mean, I don't know. Christian, I don't know what the right answer is for Bitlooney to, like, for us to help him get this resolved, but I really do want to try to get it resolved somehow. Okay. So it looks like we drive the line and then we go high Z, so that's a little bit weird. Oh well. Let's see here. So send data, do all the setup. But really what we're going to want to do is I think I want to flip USB BP and DM. And hopefully, oh no, not here. I want to flip it here, DP, DM. And then hopefully this will work. So we wouldn't be drifting after the end of the message. I would say we are not drifting after the end of the message at all. This is the default state right here. Okay, so that's good. That is very good. So, now what's next? So, right now we're just aborting out, which we don't really want to board out. What we want to do is test memory. What is test memory? Not really sure what that is. Why are we storing S1 in test memory? Oh, I guess it's so I can print it out. We don't really need to do that anymore. Then c.load immediate S1 0 and c.load immediate S0, and then that's I wish I had wrote more documentation when I wrote all of this last time, but I didn't, and so we're here now. Oh gosh, so many people. I found it was my... Anyway. Okay. Hi Dom Nom Nom. I guess let's just see what happens right now. What if we just run this? What happens? Okay. That didn't work. Oh, I guess the part must be in some sort of crazy mode. Well, that's not good. I am currently using a Sele Logic Pro 8. And this isn't really high speed. Everything with USB low speed is all 1.5 megabits a second, so it should be pretty benign. Now it definitely looks like something gets hosed after we get the initial message, so we are going to have to dig a little bit deeper. Let's see here. I see something. Is it? What is that doing right now?
I don't think this is what I wanted to do.
Why not? That's blinking.
This is right? Okay,
Yes.
cool. Okay, I think we got it now.
Okay.
I just didn't have like libusb installed or something like that.
Oh, okay. If you are up for you can go to the examples directory, and there's like a WS2812B demo, and you can play with that a little bit. Let's see here. Normally we have more people helping me with this on Discord, but I guess everybody who normally helps is asleep, so. Okay, so right now we know that we have the ability to unlock it if we can get out of this loop. So we're going to load byte S0, A0, and A0 is a pointer to the data, so that should be fine. Tell you what, let's use the debugger. Make GDB server. Over here, GDB, or it's GDB dash multi-arch, and we're going to be using rvo.elf, target remote local host 2000. Okay, so where is this problem? No, it's already exited, so somehow it's back at the main. Yeah, it's just chilling in main. So something went wrong, and it was able to exit out, and it didn't do the right thing. It didn't let go of the USB lines. So we have to figure that out. But we do know if we jump right there, everything is fine, right? Looks like it's fine. So yeah, if we abort out early, it is fine. It can just exit, that's all fine. But something goes wrong some of the time. Or all the time, but we don't yet know why. So send inner loop. Probably write out what all the registers are. I'll do that. Oh, here it is. A0 is our data, A1 is our length, A2 is the polynomial, A3 is temporary, A4 is our line state. Oh, that's interesting. What are we doing with it right now? I don't think we're doing anything with it right now. We probably should. I feel like this should make it possible for us to toggle these lines back and forth. Is A5 messed with? No, A5 is still fine. So something is wrong in this code. Send inner loop. Tell you what, let's just abort after one loop of the inner loop. So instead of c.j inner loop, let's just let that roll on to done sending data, and we will see what happens. Okay, so now if we disable it after one of the inner loops, it's just fine. There's nothing that goes wrong. I'm just going to try from a fresh start and see what happens the very first time. Okay, yeah, so you can observe that this thing happens, something happens inside the inner loop, and then it exits just fine. So I think that what might be happening is there might be an infinite loop somewhere within this assembly code. How are things going over there?
Just reading the demo.
Okay.
Trying to get into some more demos.
If you guys want, I actually have kind of random a servo motor. I don't think anybody's written a servo demo yet. So if you wanted to do that, you could do it with a PWM. Have you guys ever used a servo motor?
No.
Use a
Without the library.
PWM signal. What?
No, without the library, no.
Okay, you can create a PWM signal with a micro, and then the PWM signal, depending on the pulse width, will control where the thing is. So that's actually something that's probably tractable within this period of time. If that would that interest you? Should I go get it? Okay. These are the two servos I have. And I can give you little extension doodads. Okay. There we go. Yeah, I know I'm a bit all over the place right now, but I'm also going to have to get a little bit of caffeine in me soon, because it is very late. Okay, so what do we know? We now know that this loop here this part is fine. It's able to set up the GPIO fine now that we fixed it. Load next byte works. Oh, because we jumped to inner loop. Okay, so we don't know that load next byte works, but we think it might. Oh, interesting. So actually what we do, I forgot about this. Let me start writing documentation while we do this, so that at least in the future I can figure this out. This loads 0x00b. This creates a preamble, which is alternating lines, alternating ones and zeros. And then it sets the same state. So then what we do, we set that up. So S0 is blah, 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 blah. Then we jump into here. So now we take A3 and we AND S0 so 1. So it takes the least significant bit. And then we handle the CRC, which I'm not going to worry about, but that should be fine. Then we AND A3 and S0 again. So what this does is it re-extracts A3. So A3 is now the LSB of S0, the running word again. Up here is now the S0, the next bit to read out. And so now down here, we're going to go read we're going to do something with A3. So we compare A3, I have no idea why we do that, but that's exactly the same command. Okay, delete that. So now we compare A3 and S1, because S1 I think is the state. our last state. Okay. And A3 1. So we're only looking at the least significant bit, but that's all it would be anyway. I don't know why. So the idea, well, if it's the same bit this time as it was last time, then it's going to be, A3 is going to be a 0. The bits are the same. A3 will be 0. I'm not really sure why we need this. Then we OR S1, S1, 1. I have literally no idea why we do that. Maybe we clear it later. Oh yeah, it says will be reset if it's 0. So, if A3 is 0, that means that it's the same bits, so we're going to send a 1 bit. So it's the same bit this time than last. That's weird. I always forget this. It's always so confusing with USB because also one of the things you might want, this is a logic analyzer. You can, my attention is so split here. This is a thing that will let you see what the wires on the dev kit are doing. So if you want to say, like, send out a signal, like a pulse train, and you can Google what the signal should look like, but you can use the timer, the PWM timer on this thing to set it up. You can use this and then monitor those pins and see what they're actually doing. Like, are they going low and high like you'd expect, or are they all staying the same? And for this, you can just download the Sele Logic software. Which is, so the idea would be you would make the thing output the signal you want with that and see what it's doing, and then you'd be able to hook up the that dev board. You guys will need an adapter for that though. That's like the little brother of the one that I'm using here. Oh, here it is. And the software that you'll want is either something called PulseView, which is the open source one, or it's a Sele. It's called Logic. SALEAE is the company that makes it, and it's yeah. So give that a shot, and yeah. Hey Josh Ashton, just woke up, 6 a.m. I have no idea what schedule you're on. We are trying to do a couple things. One, the folks here are just starting to play with the CH32V, and we're going to hopefully get a little example of something else in a few minutes. And I am trying to debug my USB code and figure out why it's not able to send messages to the why my CH32V003 cannot send messages back to the host PC. You're a good boy. And Friday is being a good boy. Send 1 bit. I think the logic here is wrong, but we can worry about that later. At any rate, we say, actually I'm kind of curious, what happens if it's not? So if it's not 0, we send a 0 bit, which means we do all of this. Last bit was a physical 0. Last bit was a physical 0. We get here. Oh no, there's one person in here who is 7 a.m. for them and they haven't slept yet. Send and bit complete. Add I A1 minus 1. So what is A1?
To get ready to leave.
Hmm?
I think I might have to go at like 10:30 to get
Oh.
ready till I think I have to get up early tomorrow.
Gotcha. Okay, well that's
Yeah.
fine if you have to head out then. Do you know how to go back the way you came
Yeah.
in? Okay. And you're good for walking back?
Oh, yeah.
Okay. Would you want to hang out more?
Yeah, sure.
Okay. We should also probably like crack the door because it is very getting warm in here.
This one.
Yeah. So head out whenever it's convenient for you, and we will just keep going from there. So this doesn't make any sense to me. Why are we subtracting 1 from A1? I don't think that's right. Especially here, we're adding one to A0, A1. So where are we setting A1? A1 is supposed to be our length. I think we're blowing away A1, and that's what's going wrong. So we should totally be using A3 here, since that's a temporary variable. Okay. That might have been our problem. So let's just see if our thing goes and slams out a bunch of crazy stuff. Josh Ashton says it's super warm over here in the UK too now. Much more than it was when I was in Seattle. It's 30 degrees C in my room. Oh my gosh. That's miserable. Ugh. Oh, I guess you guys need me to shrink this a little bit. Okay. So let's see if this goes. Well, it did something, and that something is not good, but we'll just see. No, it's just hosed. Something is really wrong. Oh, Mosler, if you're interested, if you're interested, you can hop on the voice chat in the streaming voice on my Discord if you want to chat with us here. Mobius, what time zone are you in that this is the one that you could catch live? So I think this should be not A1. We have another temp. Let's use T1 for right now. We can't do that. We have to figure out something here. Oh, we can't use T1 either. T2? What's going on? this look reasonable? I would say no, but I don't know what it's doing. Yeah, Christian got it right. So the idea is that the chip is able to receive the data coming from the computer, but something about my reply code is just so utterly broken, nothing works. Mobius, the response in logic is this. Like, this is literally it. It's just, it drives the line high for a while and then goes off the line. Like, that's all it is doing. So, I don't know what it's sending. Have you found the PWM demo?
Yeah, looking at that.
Okay.
Trying to figure out what's going on.
It might be helpful to get either the datasheet and or the technical reference manual, both of which are linked in the GitHub.
Yeah, got the data sheet, but I'll check the
Okay.
reference manual too.
Yeah, the datasheet will tell you like which functions are on which pins. And you could always like run the demo and then plug in the logic thing to those pins that it thinks it's outputting on, and then like see if it is actually outputting on those pins. Have any of you guys used a logic analyzer before?
No.
Okay. Oh boy. This is gonna be, it's really a lot of fun to do it because it gives you like a graph of exactly what's going on with the hardware.
Did you get this all the way from?
Just gonna try. Oh, this is so stupid. This microphone is supposed to be C.
Okay, so let's see here. We use T1 is used for T2 is used for CRC. So T1 is used for C0 is used for T1 is used for bit or sorry, bit stretching bit stuffing. I'm going to, instead of using 1, 0, 0, 0, I'm going to just try putting a random 1 in here and seeing what happens. The answer is it still doesn't work. Why does it still not work?
Yeah, yeah. So, I'm gonna try to get this.
Why would they just jump pins?
Hmm?
Oh,
Oh, do you want more?
I know, I've got them.
Okay. I do think you will want to hook up the logic analyzer though
Yeah.
first. It's also a fun thing to like learn about. So,
Sure. Okay.
and Sele is a reputable company. So, as much as it pains me to say that, joke. Sorry, just so you guys know, the joke is that one time I was about ready to buy one of their products, and then like a week before I bought it, they raised the price another $200, and I was like really spiteful. So I made a logic analyzer using a $45 board, like as part of like a YouTube video. But no, I still use their stuff. It's really good stuff, I have to admit. So let's see here. Is this code even being executed? So if I switch the logic here, if I do dmdp, is that actually executing?
Just try it.
Okay, so that's actually really cool. It is actually executing this code, and it is flipping the state. So, bloop, flips. It's still wrong, but it flipped it, and it is doing something. So that's good, I guess. So I'm doing something shifty here with the MSB, or the second most significant bit of S1. What is it? So it is, I did at least leave some notes for myself. Bit 0 is the last logical state, bit 1 is last physical state. I feel like this logic right here is total garbage. We're gonna have to figure out how to do it. So, if A3 is, how does this work? If A3 is the same? No.
Is that what it's supposed to be?
It's a cycle. There's also
Is channel 2 supposed to have something else?
yeah, you could probably like just plug if you want to connect anything. You can all just plug into the same. There's a lot all on here.
Okay, let's see if that one.
Here's ID0.
Okay, I'll plug in. Is that channel 2?
Yeah.
So let's see, if it's, I guess the answer is if it's 0, it flips. If it's 1, it stays the same. I always forget the logic for this.
And
Is 0,
then is the master
he should flip. If A3 is 1,
Do you mind if I take
we
some
should not flip.
the whole thing?
So really what we're going to do
If you
here
want ports.
is,
Yeah.
Let's see. Which ones are we using now? Channel 1, 2, okay, channel 3. You got this.
Yeah.
you might want to like hook it up to the blinker LED at some point, PC0, in order to make sure you're actually getting like
Actually,
good
that's a
data
good
on
idea.
there,
I'll do that, yeah.
on the logic analyzer.
I'll do that.
Okay.
Yeah, try this. Ooh.
I think all of this code here is wrong. I'm also really uncomfortable with it, so I kind of want to rewrite it.
There we go. P0.
Oh, sorry.
Make sure you hook up ground, and they have to be. Oh yeah, your grounds have to be the same.
Oh, there's multiple grounds on here.
You can use any of the grounds.
Yeah, here, try this.
Oh, there we go.
Nice.
Yes.
I almost wonder if, like, it would be better to have a live stream with them doing something basic than me toiling away in the assembly mines. One of the funny things we used to do in the live streams is we would try to broadcast to other people's computers, but we never succeeded. So, like, some of the live streams were like 2 hours of people trying to troubleshoot, like, VLC and like, why is this not working? And I was trying like 10 things and never able to actually like send the data. Okay. Okay, so I'm gonna just comment all this out. Yeah, I'm doing the CRC, but it's not totally compressed. I am using T1 for my polynomial, and I do have to actually pull that out with a non-compressed instruction. The other thing is this handle CRC is done without a jump. Maybe we should do it with a jump. I'm not really sure what the right answer is there. Where is Friday? Oh, Friday's just hanging out there on the couch. It is killing me. I need to make some tea for myself. I'm sorry that I started the stream so hectically, guys. Yeah.
I think that's the same page.
Yeah. Oh, that's not a lot of information.
So the neutral is
Oh, so that's just between 500 and 2500 microseconds.
It shifted to the white tiger. I don't get it. The joke. I don't get the joke. Do not flip. Allow. So what are we using for our T1? Oh, this is complicated. So we actually need to, yeah, so we're going to worry about the timing later. For now, we're just going to get the stuff to like spew some bits onto the screen here. Send 0-bit, flip. So for this, it's going to be, So here, what we're gonna do is we're gonna flip the lowest bit of S1, but actually all we have to really do is just say like neg S1, not neg. Not, whoa, Friday! No! Not S1, S1. And then what we're gonna do is BREQZ. Let's see here. Actually, we can load A3. EQZ S1. Is it J and K? Is that what it is? USB in a nutshell. Yeah, the cat definitely has the keyboard and mouse here. Whenever he wants, he just goes and walks all over it. Electrical, JK. Shoot. I for the life of me cannot remember what it's called. It is the signaling. Here we go. Okay. So K is the default state, J is the not default state. State J. Is this really J? And we'll figure that out later. Maybe these two are flipped. A3. And then what we're going to do is we're going to output this right here. Let's give this a shot. Let's see if I screwed everything up. I did. Send 0-bit. What is that?
What's the time? Time line. 4.39 seconds. So it's 4 measured. Between 500 and 1200.
Okay, let's see what happened here. Nothing happened. Fat lot of nothing happened. Goes high for a little bit, goes low, and just kind of lazy daisies its way on to nowhere land. How are you guys doing?
Good.
do you think you're outputting a signal?
I'm not sure yet. Maybe. Let's see.
Or
Okay.
how many do you need? Just one?
Just one.
To which?
Uh,
PD0?
yeah. I haven't started yet. Anything? Oh.
Oh, ground.
Is it?
C dot add I, AI, 1 minus 1. So we subtract 1 from the number of bits we're sending? Is that what it is? A1, I think? Ending, load next byte. But you know, one of the interesting things we're doing is I don't think we're actually like, yeah, we aren't doing anything like to shift S0 back down. So we're going to try to shift S1 down. Oh, C dot. Okay, let's give this a shot. SRLI, is that what I always get the, like I'm like dyslexic with that one thing. Okay, and let's try clicking stop. Oh no, is my computer overheating again? Yes, yes it is. Hopefully not as crazy as it was before. Oh, hey, we actually got something to come out the other side. High, low, then back to default. Okay, well that's something. That is indeed something. Don't think it's the right thing, but that's something. Okay. What happens if we do more 1 bits, or like 0, 1, 0, 1? Oh, sorry.
Just don't unplug everything.
Oh, no.
Well, yeah, I know it's an error packet, but wow, is that really that slow?
Sure.
Wait, you don't have the.
How do you know?
What? Oh, do you need a USB-C hub?
Actually, yeah. Is there one I can use? Otherwise,
Yes.
it's okay, 'cause Dan
I thought there was. I think there is a USB-C hub here somewhere. Give me a second.
If not, it's no problem.
Oh, I know there is a USB-C hub here somewhere. Give me. There is a janky USB-C hub here. It is. Here. It's This is the janky USB-C hub.
Cool. Thank you.
The cursed
Oh my gosh.
combination of things. Okay, so it goes high, low, high again, and then low, dip.
Okay.
So,
I'll see you guys
see ya.
on Tuesday.
Yep. Okay, let's see what we see now. Okay, well we're getting somewhere. 0.
No, yes.
Oh,
Okay.
Friday looks so concerned. Why are you so concerned, Friday? What's wrong, Friday?
It's gonna be Saturday in an hour or so. So.
Oh,
you
it's
know.
no longer his day. So I do 1. I'm not actually sure what any of this code right here is doing. What is this? So we get a pulse for 3.276 microseconds. What happens if I change that? Ooh, I know what we could do. New session. I'm annoyed I don't seem to be able to build your code using Clang's cross-compiling. I guess I'll just install the GCC cross-compiler. It's annoying because I'm on an M1 Mac. Yeah, GCC is like on the ball with risc-v in a way that Clang is not, and I really am not sure what's going on with that. Like, Clang has risc-v support, but it's only for like some of the variants, and even then it seems... I'm not really sure what's up with it. Something's weird with it, so... Okay, so this is what this looks like. What is the 2? Okay, so this is... Ooh, we're getting closer. 0, 0, 0, and then 1, 1. So, what is going on here? It's almost like the 1s and 0s are flipped, like the logic of the 1s and the 0s. Also, does anybody remember, is USB LSB first or MSB first? I think it's LSB first. I hope it's LSB first. Yeah, I mean, I get that, Mobius. If it was good, that would be neat, but Clang is just not there. Oh yeah, okay. Thank goodness. So that's gonna be fine. So I think what's going on here is maybe we're like something's backwards, because if I make these first several bits 1s, let's see if I do it again. If it'll be, right now it's 3 bits it's reading as 1. Hopefully this will be 4 bits it's reading as 1. By the way, it's kind of funny, this is without any effort on timing, so who knows what it's actually going to do. We're going to have to work on that. but let's see if we get 4 bits. 1, 2, 3, 4. So yeah, I think something's backwards with the logic for the 0s and 1 bits. Send 0 bit. Send oh, branch not equal 0. Branch EQ 0. Okay. Let's try this. Ooh, we're getting closer. Okay, so 0, 0, 0, 0, 0, 0, 1. Okay, so okay, we are getting very close. Why does this work? This doesn't. This is like 2 bits. Oh, maybe our first state is backwards, so we can just flip this logic. dp, dm, dp, dm. Okay, let's give this a shot. Ooh, that's not good. 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0. What are we trying to send? It's super dubious. Oh, I see. These are too long. Yeah, this is way too slow. But also this is just wrong, so. Maybe the initial state is wrong? Maybe this one should be that? Nope, it's still weird. Something is wrong. Oh wait, maybe it's not. It's still very much too slow. I'm not really sure why it's so very slow. We'll have to figure that out. Yeah, I think I also now have to flip dpdm backwards again. Or maybe I should just change the initial state. No, I should. What happens if I flip it backwards again? Oh, wait, these should also be 0s. Okay, that's a lot better. 0, 0, 0, 0, 0, 0, 1. So that's... So let's try flipping them one more time. dm, dp, dm, dp. Do you know if the hub worked for you?
I have not tried it yet. It's
Okay.
connected to the
Okay.
there right now. I don't need to connect it.
I think this might be a reasonable packet, except that it's too slow. We will have to figure out why it is too slow. But 0, 0, 0, 0, 0, 0, 0, 1 then it sends 100000001. I think that's not a real token. Maybe we need to fix our timing now. Friday. Do you want to come here? You're a good boy. I guess you guys need cat cam, don't you? Let's do it. We don't need to look at the chip. Oh, wait, that didn't work. But we'll have cat cam there for the future. When Friday is cooperating more. So, not S1, S1. We are going to have to make this code faster. I'm not sure why my brain is so slow today, but I'm at least glad that we're able to send something out the port. So actually, let's see, how many cycles is this? So from here to here is 42 cycles. Oh wow, that is slow. I thought sending would be so much easier, but as it turns out, everything about USB is hard. You can quote me on that. If you guys have any questions along the way, let me know.
I'm just reading documentation at the moment.
Aww. Friday, get out of the LED box. Yeah, maybe we'll have to split the CRC apart like we did before. Okay, yeah, let's do it. Yeah, that'll be a lot faster if we split the CRC apart. Okay, well, let's see how we did it up here, and we'll just do the same thing again. Wait, did we not? Yeah, we did split it apart. So if it's a 1-bit, we do this with the CRC. If it's a 0-bit, we do that. Handle CRC 1-bit. Handle CRC 0-bit. Wait, isn't this the same code? No, they're different codes. Okay. Is USB config.h missing in the repository? Maybe. Midstream update. And it says new file. Thanks, Mobius. I did not remember to push that file. Oh. Okay, so now I believe USB config.h is inside the repository. fourth polynomial? No, A4 is not the polynomial? Is it the polynomial? A4 is the polynomial. So this is handle 0 CRC 0 bit. We're going to delete all of this code now. Is A3 up here? I should have used the same registers for the same things in both places, and then I could reuse this code. I still might go back and do that. So what is it though? What is A0? A0 is temp. A3 is the running CRC. Okay, so down here those are different. What is the running CRC down here? A2 is our CRC, A3 is temp. Okay. Oh, but the reason well, yeah, we could use anything we wanted. Okay, so A2 is our CRC, A3 is temp. A2 is our CRC, A3 is our temp. A2 is our CRC, A3 is our temp. Okay, I think that's right. And then we need to do handle CRC 1 bit. A2 is our CRC, A3 is our temp bit. A2 is our CRC, A3 is our temp bit. And our polynomial is T0. Okay, let's see what happens now. Oh shoot, 480. And A3, T0, and A3. Okay, let's see how this goes. Do we have any hope of this working? Let's see. Well, are we any faster? Is this just as slow? Am I gonna be disappointed? 39, okay, sure, whatever, we're like 2 cycles faster. Why is this so slow?
I'm still trying to understand exactly how to set this. I don't really understand what this part is doing. That's what I'm trying to figure out.
What is the question?
I'm just kind of, just trying to figure out how I'm still trying to understand the PWM demo and just how the actual like pulse width is getting set.
I believe it's let me look at that right now. I don't think I was the one who wrote the PWM demo, so which one is that? That's Tim1 PWM, I guess?
Yeah, that's what I'm looking
I believe CH1 CVR and CH4 CVR are where the pulse widths are set. And ATRLR is where the period is set. So the period becomes, I think, ATRLR plus 1, if I remember right. Or maybe it just becomes ATRLR, and then 128 becomes the period. Or not the period, the duty cycle. So 255 is the period, 128 is the duty cycle. And with the prescaler set to 0, it should be a 48 megahertz like clock divided by 256. Now that's the whole, like, yeah.
Okay.
I think we might need to rethink how we're using these registers. This is really depressingly slow. Let's take a look at some of the, we'll just do our normal bag of tricks and see where we end up. Is this aligned? No, this is not aligned, so that'll be an easy win. Okay, so now it'll be aligned. Next. Let's just split this apart so we know what we're doing. E3, S0. And A3, 1. So this is for instructions, that's aligned, send 0 bit. Okay, so and I should be aligned. C dot and I 3. Let's see how this is set up. So let's make this again, and let's take a look and see if this is aligned. So one of the things that we found out before was that if you jump to things that are unaligned, then it will take extra time to handle the jump.
Yes.
And that's just really depressing, so. We'll just put an extra knob in here. Okay. Let's see what we are now that we've, I believe we've aligned both of them. Let's make sure that that's the case. Okay, so now this is aligned as well. Oh, that's also aligned, outstate J, but cond jump after is aligned. Okay, so. I think we might have just hit like the worst case for all of our alignment. Now I think we're in a much, much better place. We still have to align and with this. Okay. Okay, let's give this a shot. We have a shot now. I mean, it's spicier, but that's not a good thing. Great, we're now up to 40 cycles. We've added alignment and we went in the wrong direction. We have to get this down to 36 cycles. This just has to be 36 cycles. Why can we not get the 36 cycles? What is wrong with us?
1
can we not get to 36 cycles? So let's just cycle count and see where we end up. 1, 2, 3. Four. Wait, send.
Yeah, try everything.
Which channels?
6, 7, 8, 9,
Is it upstairs?
10, 11, 12, 13, 14, 15, 16, 17, 19,
Okay.
20, 21, 22, 23,
Yeah, that's right.
20.
Just try to get this out and see.
4, 25, 26, 27, 28, 29, 30. No, this should totally be fine. What are we doing wrong? Why is this taking so long?
Does the duty cycle change for different servers, or is it like?
It is different.
Oh, okay.
You'll probably have to experiment.
Oh, okay. I won't break it by like.
Nope.
Okay.
Cannot break it. And I think that's a 5-volt servo. So,
Okay.
and you can use 5 volts from the programmer. So if you unplug, I think it's right now hooked into 3.3
Yeah.
on the programmer, so you can swap it out for 5
Okay.
on the programmer side, not on the board side.
Okay. Oh, I see.
Although it might be worth making sure that those servos are that. I don't really know. Maybe Google it?
Okay.
I don't know much about those servos.
That's one.
We're just more hacking away at the CH32V003, not necessarily any specific. Are they the dinky blue ones? No, they're these weird red ones. Here, I can take it and show the camera. It's this thing. I don't know it. It says 20 kilogram DC 4.8 to 6.8 volt DS servo, digital servo. Yeah, oh, it has a part number. DS3218MG. DS3218MG. Maybe somebody in chat has used it. Okay. But yeah, you can't harm them from like what you drive, so. Well, it said 5 volts, so you're good. Do I have any more registers I can use? Because I would love to just use a different register, and I don't. Feels like we're just always out. Here's A5. Oh, that's the port address. I don't want to mess with that. A4? Do we use A4? Ooh, A4 is it's one of the suite registers. Okay. So A4 is free. So let's see here. Can we do something here? So I don't really want to mess with that, but it would be nice if our polynomial was there instead of t0. Ooh.
I was setting it to 0, like 0 degrees.
Okay.
Oops.
Ooh, I just remembered. No, risc. Does it even matter if we yeah, I'm aware that CH released their a new chip, but if it's not 10 cents, I'm not really interested in it. So that is the whole point here. Yeah, people seem to like assembly language programming. I don't really understand that one. And it's even crazier because even though there's only like 19 people watching right now, I get like 1,000 plus views on the actual like replay, which is just insane to me. But okay, so what I want to know is, I never remember this, but there are some commands which allow you to use registers that are the full 5-bit registers. So I guess it's add I is good, add IW, but I think and or, those only use compressed. So okay, yeah, this is good. So c.and. Okay, so now that that's fixed up, we can get rid of that. And I think we can get rid of that. No, we can't. Assembly, best served live. Yeah. You know, I'm thinking that might not be the best one because we use T1 in several places here. Yeah, I think T1 might be the better one to move to the compressed state. Yeah, let's do that. Let's at least see what this looks like. I'm not even going to bother looking at the output. I just want to look at the assembly code here. I want to see how bad our synchronous, or our, what do you call that? Our alignment is. Okay, that's good. That's wrong, but okay, fix one thing at a time. I mean, let's just fix everything, not one thing at a time. The opposite of what I said. So let's put this there, that there. Let's give that a shot. What do we get? Okay, so B4, that looks good. BC, that looks good. D8, that looks good. FC, that looks good. 0, 0, that looks good. 4, 0, 6, that's not good. Okay. Send bit complete. Okay, I think now we might be good. Let's give it a shot. Now it looks like it's still not fitting, but let's at least count. Are we at like 38? Are we anywhere closer? We're 38, so we're getting there. We have to get 2 more cycles clocked out of this thing. Then we might be talking about something. Ooh, what was that? Was that intentional?
Yeah. Well, yeah, I'm just playing around.
Okay. So that's 66.
Yeah.
I just realized it's not 36, it's 32 cycles we have to get to, so this is going to be even harder. Maybe we have to pre-compute the CRC. I don't want to do that. No, there's got to be a way. This has to be possible. We're so close. Was it? No, it was originally like 40 cycles and then 36. Was it 34? Did we get it down to 34 and now we're back up and I'm just like taking crazy pills? That must be it. So let's count the clocks here. What do we think we have? So that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. This is disgusting. This is so much. It makes me so sad. We should fix that. Yeah, we should totally store these somewhere. T2, is T2 still free? Yeah, T2 is free. So what I'm going to do is I'm going to load T something and T something else with these. And we'll see how it goes. So T2 and T3. We don't even have to do this. We can do this directly. don't actually know if this is going to be any faster. I don't know what MVA3T3 does, if that's like a short command or a long one. Let's check. Okay, so c.mva2t3. Is that valid? Oh, yes, it's valid. So yeah, T2 and T3 are going to be great places to store this. Okay. Oh man, I wonder if we can do something clever where we would conditionally select.
There you go.
Hey! Did the kit come with extra junk to screw into it?
Oh yeah.
Yeah, give it a shot. I'm curious how strong it is. I don't really care if you blow it up, that's fine.
Alright.
We're interested in adding this to the CH32V003 because, well, because it's hard. And mostly because it's inexpensive, but also just because it's hard. Check Discord for my nicer instruction list. Okay, where in Discord? Oh, architecture discussion. I will bring that up over here. Oh, hello! This is beautiful. Okay. Thank you, Mosseler, for building this. This looks so good. Okay, so c.move. Oh, nice. Okay, so add and move are both compressed instructions even when using all of the registers. Oh, that changes a couple of things for me. Okay. Oh, I also wanted to ask, Mosseler, I believe you should explore this. There are other undocumented load and store instructions. I don't know their purposes, but sometimes the official, like the real Maun River Chinese SDK actually outputs like these weird load and stores, and they're still load and stores, but they're for like double precision floating point and whatever, but they're not used, like the chip doesn't interpret them as that. They're just like they do other behaviors. So it would probably be worth it if you were to go give that a shot and see what those other weird load stores do. Oh, this is neat. What? Oh.
I don't know. Yeah, there you go.
Okay. So it looks like Dan here has a little servo up and running with the CH32V here. How much force can that thing apply? It says 20 kilograms. I'm super cool. Oh gosh, I would not get your finger caught there. Okay. So the answer is that's terrifying.
Yeah.
Huh. Can you, if you safely hold it, do you think, oh, Friday's interested. Is he kind of bad at it? Sometimes he bats at stuff like that. Maybe you should make it so it can't chop things off.
Yeah, that's a pretty good idea.
Okay, I would turn it off right now before he gets... Yeah. That's a little scary,
Yeah.
the amount of, like, when I saw your hand
Yeah.
in there, I was like, oh! Okay, I think this is gonna work out well. Because now we can very quickly jump between it. So, I guess then what I would want to know is we want a way to flip between the states, and we want to select between T3 and T2 based on that state. Is there any fast way we can do that? Man, I wish I wish that like x0 was not 0 and that x0 was like all f's or something. Ugh. Or 1. Yeah, it'd be neat if it was 1. Anyway, so we say not S1, S1, move C dot blah blah blah. So the idea is that A3 is T3, otherwise A3 is T2. We jump here, we store the word. We actually need to add a nop here so that it takes the same amount of time. Okay, let's see how we're doing on alignment. Oh boy, this is not good. 433. Wait, what's wrong with that? That looks like a perfectly cromulent line of code. Is T3 not a thing? T3 isn't a thing. Okay, so instead of T3, we'll use T1. Wait, XOR dest? Yes, but it's not the compressed XOR is the problem, Mobius. I want to be able to use the compressed XOR. Honestly, I just wish that there was like the Charles version of the risc-v ISA, which was everything is a 16-bit instruction. 434. A3, T2. A3, okay. Let's see how our alignment is before we go jump to any conclusions. Okay, so that's aligned, that's aligned, that's aligned, that is not aligned. Conveniently, though, we can force it to be aligned by doing that. Okay. Can we make it any tighter? See, the not is what I don't know how to do. There's got to be some way of like quickly flipping that. Like, there's got to be some compressed instruction for saying like not S1 comma S1. Wait, I had another random thought. Can we just XOR S1 with 7, 0? Oh, wait a minute. We might be able to cheat. Is 1 if we should, or 0? Dang it! If it was the other way around, if A3 is 1, then we should flip, then we could just XOR that there, but apparently not. So send 0 bit, so that's if A3 is 0. Add I A3 1 C dot XOR S1 A3. Oh, that's gross. Make A3 equal 1. Invert the running state. Okay. Okay, what does this code look like when we... Okay, FC 40404. Okay. I don't really care about this one. This can be unaligned. Okay. let's give it a shot and see how it goes. Very, very poorly is how it goes. Very poorly. Very, very poorly. So that broke everything. Let's see if we can figure out why we broke it. Everybody is saying good morning. It's funny, I'm finally catching the Europeans. Okay, so here we got something happening. Let's count the bits. Let's see if we have any hope at this.
I think I'll be on.
All right. Well, cool. Do you want to make a PR?
Yeah,
And
I'll make a PR and submit it.
that's pretty cool.
Good. I'll probably head out there.
All right.
As well.
Cool. Well, thanks for dropping by. Did you guys have fun?
Yeah, yeah, this is cool.
Okay. And you can keep your little dev board things if you want. There's no obligation. So.
No, I'm definitely.
Okay. Sunny Saturday morning in the UK. I'm in bed watching live assembly. We have another Brit here too. All right. Okay. So we're down to 34 instructions. That's pretty close. It actually, no, it's not going to be pretty close. We actually have to do much better than that because we have to handle for when we load a new byte. Well, that's annoying. Hmm?
Oh wait, feed's back up. Yay.
This is my idea of a good Friday night. Yeah, for you guys it's in the morning, but for me it is almost midnight. My goal though is to stick to this until we get something working. So I really want to be able to have a device enumerate tonight. I'm probably going to just keep going till like 5 a.m. if that's what it takes. So. Why is this 34 cycles? Let's take a look at the assembly again. See you guys.
Have a good night.
Thank you. I lost count. Okay, so we're going to count these now. So what we have is the inner loop is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? Wait, I'm missing something. Wait, what am I missing? We have to send 0 bit. Where's that called? Oh. 14, 15. so no, we need to handle 0 bit. Okay, so let's count again. We're going to say for 0 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I did it wrong. No, we're jumping to the 0 bit. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, oh, 8, 9, 10, 11, 12, 13. That's really gross. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, what? Oh no, there's like some weird junk in there. That's not, those aren't instructions. 3, 24, 25, 26, 27, 28, 29, 30, 31, 33. Okay, so really it's just a lot of stuff that we're doing. We have to do less stuff per bit. We have to find a way to do less stuff per bit. A lot of less stuff per bit. How are we going to do less stuff per bit? Also, I'm going to delete all this because we now know we don't need it. This is so gross. There's got to be a better way to do this. Wait a minute. No, I think this is actually right. I feel like somebody somewhere posted some faster CRC code, but wow, this is annoying. Okay, well let's at least see how fast, because I'm just morbidly curious how fast the setting 2 bits is. Cycles, so wow, that's really annoying. All of this is really annoying. Let's see, how long does this part take? So 34 or 36 cycles, depending on if it's high or low. Yerf. Yerf. Oh my gosh. Surely there's a faster way to do all of this. Okay, let's think at a high level what we're going to do here. High level. We're going to extract the LSB from S0. If it's 0, we flip the USB pin state. And how cool would it be if there was like some bit you could set to flip the state of I/O? Like, that'd be awesome. That'd make me so happy. Why don't they do that? Anyway. If it's 1, we don't flip, regardless of the state. We still compute CRC, and we have to increment or decrement our bit stuffing index. If it is 0, we can reset our bit stuffing index. Yeah, I know that there's the bit manipulation extension, but we don't have it here. So one thing I'm immediately noticing is this is going to have to be inflated. Like if we're sending a 1-bit, then we don't have to switch the I/O state lines. So there's that. Man, I wish USB did it backwards. I wish that if it was a 1, you flip the state, and if it's a 0, you don't. I mean, we could always just like neg here. But then it's hard for us to do all of this. Actually, I can't remember. Oh yeah, okay, we have solved. Okay, so. Is there any kind of instruction that we could abuse here? Like, it feels like this should be optimizable. Like, we just want to say, is the LSB 1? And shift it down, but... Oh, yeah. I'll point it down at him a little bit more. Oh, and we can turn off this camera now. Yep, Friday is on cat cam. Anyway, I don't know why I'm struggling with ideas tonight. I feel like there's gotta be better ways to do this. Like, this right here feels so janky. I want to load. You know what? Actually, we can do something even better. We already know what the state of S1 here is. Oh, heck yes. Oh, we can do this. Branch equal to 0, S1. Oh, can we? I was thinking we do something like, so let's see, does this work? So first time through, S1 is 0, outstate J, add I minus 1. Well, that doesn't work. What if we do add I plus 1? Well, that doesn't work either. Does it? 0, 1, so now it's not 0. So now I'll set it to 0, set it to -1. Ah, that might work. Let's see, does that work? Is that even possible? Maybe. Let's take a look. Ooh, that visually looks interesting. Let's see, are we any closer? Or is my brain just playing tricks on me? 34, crud. And the other bit is, I'm gonna guess 36. Yeah, we didn't win anything. So, I'm really curious, what is this a 32-bit instruction or no? No, it's not a 32-bit instruction. I've blown all of my... Yeah, I blew it. Can we take one more pair of bytes out of here? Mobius, I'm hoping to get a USB stack running on the CH32B003. Although, wait, oh, I think that, oh yeah, I mean, we've been kind of talking about that back and forth. I don't know why I thought about that. You've been here the whole time. This feels like there's got to be some way to do it with this. Oh, I don't remember. Oh, yeah, I do remember. So let me explain what I tried doing here. What I want to do is I want to take A1, not A1. I want to take S1. So the idea is I want S1 to toggle back and forth. So instead of using not, which is a 4-byte opcode, what I can do is I can say, well, if our state is 0, then set it to -1, add 1, and our oh, never mind. If our state is not 0, set it to -1, and then when we add 1, it'll become 0. And if our state Friday, no, ow. No bitey. I'm not sure why he's so bitey right now. Anyway, if this is a okay, sorry. What I want to do is I want this to toggle back and forth. If this is a 0, then it'll jump here and it'll become a 1. And the next time around, it'll be a 1, it'll go here, it'll be -1, and then it becomes a 0. And then that way I can toggle it without the 32-bit opcode. But it is a little dirty. Okay, it's very dirty, but... Here, this is actually got to do more stuff. So c.nop, c.nop, nop, c.nop, c.nop. Let's just do that for right now. So what we actually care about is this. So let's make sure send 0-bit is aligned. EA, it's still not aligned. Okay, so now it's aligned. All this stuff happens. 406 is not aligned. You know, that's probably fine. We could probably just do that. It's probably fine. I guess we'll have to see. EC 404. Okay. So let's see. What does this actually work out to now? That's drunken. What? Something is very wrong. What the heck? Let's just count our clock cycles and see if we've gotten any better or if we're still in the same doghouse. 34 cycles and, let me guess, 36. Okay, you know what? There was somebody on the internet who made an issue on GitHub, CMLore, RVO for USB, who was saying something about the better sequence for CRC calculations. Let's just take a look. I'm gonna just believe that this person knows what they're doing. Is this any better? So, let's see. So if we're handling one, this could be slow as molasses. It's fine, because we're not flipping any bits. The 0 bit is the tricky one. So, let's see here. Also, I just had a random thought. We could be really clever about this. Well, alright, let's look at the CRC first. And then so I don't forget, execs to do, clever idea, XOR the output. We'll work through that in a minute, but I have another idea for this. So let's take a look. So do 0 CRC. I know the CRC won't work if I just copy this code in, but that's probably fine. Let's see here. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 instructions. Let's recap what these things are. A2 is our running CRC, A3 is temp, and A4, no, T0 is poly. Okay. I don't think c.xori exists, if I remember right. Does it? No, there is no c.xori. Oh, yeah, no, it doesn't exist. I don't even think there's a, is there a c.xor? There is a c.xor. Yeah, Mossler says no c.xori. Yeah. I wonder if the people who wrote risc-v ever thought that I would be here right now cursing. Like I'm sure there was some meeting of like, yeah, but who would like who uses XOR that much that they would need it in the compressed instruction set? Okay. I think that that's right. 6x warning. This was by this to do check me. Mossler, I was able to see that message. I'm not sure if it got yeeted or not for others though. Can everybody in chat see Mossler's message? Okay, surely this will compile in time. Oh, well, 514. Okay, fine. 514 and I. Wait, what is this? And eyeing. No, he never wrote what he was. Oh, what did you mean? What's the? Is this just c.and? Maybe it's c.and? Oh, but you can't and. Whatever. Let's see if this is any better. I feel like there's like sad trombone music that plays every single time I measure this. Oh, 32, okay. It's still not fast enough, and 34, okay. So we did successfully save, assuming that they knew what they were doing. We just saved a cycle or something. Now what I want to try is, I want to try my like little clever idea. So what I'm actually going to do is store in I guess I thought that was 0 to begin with or something. I want to what are we using for the temporary variable? A3? Well, we're using S0 now. Because we're setting that later. Okay. So what I'm actually going to do is I'm going to store, this is a little weird, I'm going to store alright, S1? Yes. S1 is going to contain the USB state. It's going to be S1. And T1 is this really bizarre thing, and what it's going to contain is it's going to contain all of the possible combinations of these things. And then what we can do inside of our code is, instead of doing all of this junk, we can say XOR S1, S1, T1 in order to flip it. And then we can say store word S1, all of that. We have no need to update S3. Okay, so maybe that'll work. I think that this works. Because what we're going to do is we're going to, like, it's going to be a bit mask of, 1, 0, 0, 1, and we're going to XOR it with 1, 1, 1, 1, and then it's going to become XOR with and then it's going to become 0, 1, 1, 0. I think this might work. Okay, let's give it a shot. Cycles, okay. 30 cycles. This is good. We still need to be faster because what we're going to still have to handle is for when we need to read in another byte. But that's pretty close. I think we have to get it down to 28 cycles, if I remember right. The reason being is that we have to be able to call this at the appropriate time. Load next byte. I think that that's correct. So c.nop, c.nop. We should also check our alignment. Maybe our alignment is off. Let's see. I'm just curious what this line's up to right now. Gosh, though, that's starting to look really pretty. I think this is going to be 33 if we've calculated everything right. 32. We might have enough time actually already. Okay. 32. Well, this is looking mighty fine. Okay, so let's see here. 0, 0, 0, 0, 0, 1. So that's not quite right. What we should see is this should start back here. So, let's try this combination and see what this does. I actually don't know how this is going to behave, but yeah, this is a lot of fun, like going DIY, like going from the really awful long thing to a much shorter thing is very cathartic. 1, 2, 3, 4, 5, 6, 7. Now, one of the interesting parts is this part here looks like it's a wee bit short, but that's actually kind of to our benefit. Yeah, 26. That means we can do a little bit more work in the beginning, and we can fix that up later. But so we have 1, 2, 3, 4, 5, 6, 7. Well, that's not right. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Ah, darn. Maybe I'm doing something wrong? So, doing the inversion did work. Yeah, we're supposed to be sending the preamble. It's supposed to be 8 bits. What do we initialize S1 to? Wait a minute. Oh, A1. What do we initialize A1 to? No, that's right. So it should be doing 8. That makes sense. shifting too early or something? Am I shifting too early or something? I'm not really sure. We gotta make that line up. Like, USB hosts are not going to be happy about this. Huh. So we start at 8, 7, 6, 5, 4, 3, 2, 1, 0. That's 8. It should line up. No, we're doing the subtract here. Wait, is there c.xor? I can't remember. Did we already try that? Yeah, there's no c.xor. Okay. Hold on. Mobius, I'm gonna just commit this. Oh, okay. Well, I'll commit this anyway, and we can tweak that later. Mid-stream update. Okay. Well, let's try that. c.xor. Okay, that would be fun. Well, still, this doesn't make sense. Like, we still have to find out why this is wrong. Because send 0-bit should be the first thing through here. Let's see. So branch equal A3 equal to 0. And A3, sorry, S1, MV A3 S0. I'm working my way backwards, and S0 is this. So this is 0. So the very first bit through should be a 0. Maybe the state of the lines is wrong here. Oh, I think we can't use... Yeah, we can't use it because T1 is not in our lower bits. I forgot about that. Or not lower bits. T1 is not a register that we can use with that. So. One, 2, 3, 4, 5, 6. Well, that's just great. Maybe if we wait here longer. We're not here. Where is it? Is it here that we want to wait? I think it's here we want to wait. Theoretically, this would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so theoretically this would be right. I have literally no idea where the first bit is going, though. That's a little disconcerting, but sure. yeah, you're right. I can add 1 bits to my preamble to see if something got chopped off. I think I may do that. Let's at least see if, right now, we just hacked it all together. Let's see if it at least adds up. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it all adds up. Let's see where we have to add some extra knobs. So that's 23. How many are we missing from the next one? Okay, I think this is going to at least give us something that lines up. Hey, Adam. Adam, I believe you can join my Discord voice. I think. Assuming that, yeah, I think it'll come through. Or is Adam not in that group? Okay, let's just insert an extra 1 somewhere random. Let's do it here. And let's see what comes out the other end. Yeah, Adam, so we have a specific Discord group for chatting on air. So if you're willing to like hang out there and keep everything super on topic, that would be really cool. Okay, well this is a nightmare. 1, 2, 3, 4, 5, 6, 7, 8, 0, 0, 0, 1. What? Excuse me? What? How is this even possible? Oh boy. Mossler, are you making like a jab that like I'm gonna just keep streaming until I die, like, because I want this to be solved so badly. So I have. Okay. So I am so confused right now. Zero, 0, 1, 0. What is going on? This all would make sense, it's just that it doesn't. Why? So like theoretically this should be 10 bits, because I don't know if you guys are seeing this. When I send, it seems to be showing the bits like kind of where they should be. But like 1, 2, 3, 4, 5, 6, 7, 8. Why? I wonder what happens if I put a 1 here. Maybe I could trigger on channel 0. I don't know, maybe. Yeah, I guess we could do that. Yeah, so it... What? So I really hate this. This just doesn't make any sense that... Okay, sure, let's do it. How do we do that? Capture, trigger, channel 1, channel 0. Okay, let's go. Wow, that actually worked out really well. Thanks, Mossler. Now, let's see if we can figure out what in the world is going on. 1, 2, 3, 4, 5, 6, 7, 8. Why are the... What? Okay, let's replace that with that. You know, I'm just gonna assume everything is fine. I don't really understand this. Let's see if the rest of the packet looks good. 1100 0011. Oh wait, I know why this worked. It's because it came from the PC. 0000 0001. Okay, well that also worked. Then 0000 001. Okay, so I have no idea why it's working now and it wasn't working earlier, but... This looks wrong, though. I guess this is like... I don't even know what it's trying to send it, so... Let's just do li s0 0xaa. Sure. Oh, wait, that actually kind of worked. 0 1 0 1 0 1 0 1. One, I guess? It's like something's ending like one something, well, 1 2 3 4. 1 2 3. Oh, no, that is right. Okay. Oh, that's good. What was, I don't understand the question, Adam. I wanted to measure a phase difference delay in microseconds between two signals via DC coupled DAC. I saw that measured in your software, Charles. Is it sampling theoretical simulation multisim? I don't understand your question. don't understand, what project are you referring to? Did it show the microsecond gap between the change in hardware, or was it a simulation? I mean, I don't understand what you're looking at. Are you looking at the Sele, or are you saying something on the WCH part that's doing this? This looks like it's actually working correctly. Is something corrupting A0? Doesn't look like anything is corrupting A0. Right now, I don't really care what the CRC is. I want to understand why I should be able to read the first byte from here, and it should be good. Oh, also, you know what we need to do is we do need to do a single-ended 0. Okay. Error. Good. But the fact that it is able to now actually identify the single-ended zero is good. So 1, 2, 3, 4, 5, 6, 7, 8. I don't know where the extra 1 is coming from, but I don't really care. It's not right now. Oh, C dot not. Oh yeah. Sorry. Thank you guys in chat for helping each other out there. Actually, total side note. I am really curious how long this takes. Please be about 70. Are you kidding me? Let's just go revisit all of our alignment again for the umpteenth time. Aligned, 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 aligned. Okay. By the way, thank you for recommending that Mossler to do the trigger thing. Well, I'm actually a little bit confused there. Why would it immediately respond? Does it think this is almost a valid packet, maybe? I guess it probably does. That's a good point. That was another thing I had like on my list to do, was add B-aligns. Yeah, let's do that. And these last ones we really should B-align. Let's make sure this makes sense. So in that event, we jump up here. And we jump down here. Okay, so that looks good. I'm just really confused by what I'm getting here, like the data. So this should be the preamble, 1, 2, 3, 4, 5, 6, 7, 8. Then we have a packet of some sort, but it looks wrong, which is 0, 1, or 1, 2. 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. We have an extra bit. What is this trash? Am I like you were asking earlier if I was off by 1 on the shifting or something. I don't know how I could possibly be, but maybe I am? I don't get it. I don't know how that's possible because I'm not shifting until after I load into A3. actually, if we're going to use B-align, then I guess this matters much less. I'm going to just run this a few more times to see if I can figure out what is going on. Is it just me, or is it now sending absolutely nothing? Friday. Cat alert. Does this just not work at all when I add some B-aligns? I think Friday is maybe about 3 years old now. Don't really know. We found him in the woods. Actually, he got his name on a live stream a long time ago. I think Miles Flavel, if I recall right, said name him Friday. And I was like, that's a pretty cool name. I'm not sure why my data got eaten, so I'm going to undo all the B-aligns and see how things go. Yeah, I don't know what's up with that, Mosseler. I added the B-aligns and things got bad. I mean, even if the assembly does fill with NOPs, that should be fine. But sure, why not? Let's find out. I mean, that's odd. I didn't think I needed the B-align here, but okay, sure. Well, that's aligned. That's already aligned. That's already aligned. Well, now I'm a little weirded out. Why did it insert this? Was it unaligned at some point? Friday is being adorable. Although it's very hard to see him. He's playing with the light. a good boy, Friday. Yeah, I don't know what's going on, but when I do that, it eats up my knobs. I have no idea why the B-align is doing this. I'm really curious now, though, to see what is this output. How? Okay, let's only B-align load next byte. Everybody, let's go take this code right here, copy it, paste it in a new thing, and compare, because I don't understand this. It must have inserted code somewhere up above for some reason when I added the B-align. What is that code? I'm not sure. But it was already aligned to begin with. Figure out what it is it's doing? Wait, how? What? Okay, I'm going to copy and paste this whole thing in here, and then we're going to go compare. No polynomial. So this is the aligned and this is the unaligned. The aligned has this one unaligned, but that's fine, whatever. Okay, let's look. USB send data. 376, 374. So they are in different locations to boot. Maybe it just... Oh, let's just B-align the other stuff too, up above. Did that work? No, it did not work. Something is still very broken. So 378. Yeah, I know I should abandon it, but like, what in the world is going on here? So it's off by exactly 4. of this code looks perfect except for some reason it's off by a little bit. Just like New Jersey. Yeah, all of this looks perfect. I don't know, it looks like it's exactly the same code, but for some reason it's just not working. Okay, fine, I give up. I'm not going to use B-line. Next up, what in the world is going on with this packet? Okay. So in here, what we're actually doing is it's saying send now. So PID handle in. Oh, interesting. So this includes the preamble. Oh, that's annoying. Okay, well not only is that annoying, isn't that like wrong? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's wrong. It's just straight up wrong. I mean, like, I'm actually kind of glad that they have something sane where they're putting in the preamble, but Friday, what am I gonna do with you other than cuddle? The code is being mean, Friday. Must be nice that you don't think about code at all. You're a good boy. I'm curious what happens if I set this to like 81. That didn't seem to work. Let's try that again. Seven. How is this only 7 bits? But 82. Does that? I definitely need the emotional support right now. I feel like I am taking crazy pills and it is all my fault. Like, the bug has to be in my code. It is my problem. I am the one who is at fault. What am I doing wrong? What is going on? Is this not the code that's being executed? Well, that sent a whole lot of something.
I'm thinking it might not be this, so. No, that's like literally the only place this code is called, so it has to be this. Oh, handle data. Oh, it could also be here. Okay, let's take a look at that. What happens if we set that? Oh, hey, look at that. That looks better. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's correct. I don't know if sanity is restored. That's a bit of a stretch. One, 2, 3, 4, 5, 6, 7. Nope, sanity is not restored. Sanity is very much not restored. Okay, let's just put a 2 in here and see what happens. Okay, so this is right. So that's a 0, 1. So it's 1, 2, 3, 4, 5, 6, 7, 8. Okay. What? Why when I load 8, 2 in here, does it produce this? 1, 2, 3, 4, 5, 6, 7, 8. When I load 8, 0 in, it produces nonsense. Let's try C0. One, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2. What if I do 8, 0? Two, three, 4, 5, 6, 7. What in the world is going on? Why? So what if I make this A? 1, 2, 3, 4, 5, 6, 7, 8. And that's correct. What is going on? I'm aware I have only myself to blame. Let's extend off the end of this a little bit so that we can this looks a little bit cleaner. 1, 2, 3, 4, 5, 6, 7, 8. So this is A. So the idea is that it's read this way. So the most significant bit is a 1, a 0, a 1, 0. That's an A. So that that looks pretty reasonable. That looks completely, totally fine. But then if I switch this to 8 and I record, and we'll see what it does. I'll bet you it's gonna be janky. Is janky. Let's see. 1, 2, 3, 4, 5, 6, 7. And then it just does stuff. I don't know what's going on here. This is infuriating. One, 2, 3, 4, 5, 6. This is just wrong. Like, how could I be messing up this logic? It's here. How about this? Let's just comment this out and see what happens if we just run the code the way it wants to be run. Friday hears somebody walking around outside. It's okay. We're not in the woods, and it's not a bear. Well, wait. Well, that worked. Why did that work?
Well, it's still doing enumerate, so it's not like everything magically worked, but we should probably fix things up when we're done too. I think that's right. I mean, it's working, but why? No, it's not that I changed nops. I changed... What did I even change? I changed this. I changed the data that I'm sending out. So, I mean, sort of. It's not just the data that I'm sending out, but I changed, I changed it so instead of using a pre-canned preamble, which is what I was using, it's now using the message from ESP USB. But that doesn't make any sense at all. Actually, here, let's test this. What happens if we send 0x80 twice? If this breaks it, I'm just gonna just going to do something. One, two, three, four, five, six, seven, eight. Good. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is like all kind of wrong now. Oh, right. Bit stuffing code. Could that be wrong? Because this looks like this could be. Oh my gosh. If this is the bit stuffing code, I'm going to be so sad. So if it's a 1-bit, oh yeah, this is all wrong. This is all wrong. If it's a 0-bit, that's when we have to do all of the stupid this logic. Yeah, bit stuffing is after ones, not zeros. So here, this is send 1 bit. So we have to actually like do our bit stuffing stuff. Okay, well, let's give this a shot. Let's see if it's as bad as I thought. Maybe I'm just crazy. Okay, let's see here. I'm sure our timing is going to be like super off now, but that's fine. 1, 2, 3, 4, 5, 6, 7, 8. Good. 1, 2, 3, 4, 5, 6, 7, 8. Good. Oh, that's gorgeous. Let's see how long this is. Ooh, let's see how long this is in cycles. $66, that's fine. We have like a couple knops in there to spare. It's fine. Let's see, what about this one? 32, oh yes, how wonderful. Okay, we'll get this. We'll get there. This is gonna happen. This has got to happen. Let's see here. What do we do? Okay, let's go back to the code, undo that, actually send the right thing, and then let's keep debugging our USB, because now we understand what's going on. Who knows if bit stuffing is right or wrong? Who knows if the CRC is right or wrong? Who cares? We're just going to see how this goes. Okay. Restart. Sure. Let's see here. We send that. CRC okay. PIDAC. Ooh, PIDAC. That's pretty good. PID in. And so let's just see here. PID in. address, an endpoint, an EOP. Okay, so it probably got something there, but for some reason we didn't see fit to ack it. So what does the code do for a PID in? PID in. PID in. Handle in. Does a bunch of stuff. Uh-oh. Does this. Does that. Does that. Are all of these handled? I think all of the cases are handled. Yeah, all of these look handled. Something must be falling apart, though. Do you think that maybe, hold on, do we ever talk back after that? Oh yeah, no we do. So it's not like we forgot to set up the interrupt again or something. But we never respond to these packets. I have an idea. Let's put a printf in some code. Oh. Maybe it thinks that the CRC is wrong? Maybe this is wrong. Oh, Mobius, this code right here. So sync PID in address CRC. How big is the CRC here? Looks like the CRC is 1, 2, 3, 4, 5 bits. So that's good. Let's just go ahead anyway with this. And I would know that this magical extra value is int, what is it? CRC out. Okay. Let's see what CRC out is. Oh. Clean all monitor. Oh, whatever. I don't care. Stop warning me. You know, back in the day with C, you never even used prototypes. You just kind of called functions and the linker found them and just executed the code. I never had to update this stuff. Let's see how this goes. Oh great. Caught the tail end of that one. that's fine. Let's do this. Boiling. Okay, let's just try this and see how this goes. Hey! Well, that's interesting. I would say that, yes, it does look like our CRC is wrong. Yes, Charles.exe has stopped working. Okay, so our CRC is bogus. Why is our CRC bogus? Bogus, bogus, bogus. 'What do you mean this is not surprising? It's surprising to me. I would hope our CRC works. What? No, this is the receive CRC. The received CRC was, we like vetted that, I thought, I think? Did we? Perhaps we should, well, I don't even know how to test this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, then we have this here. Plus 5 is 16. That is 16 bits. Let's at least make sure that, like, the CRC testing code is doing the right stuff. Oh, wait, we can just see if that's already the thing. 0, 1, 0, 0, 0, 0, 1, 0, 0, 0. Okay, so yes, that is the thing. I think what might be happening is we might be getting an extra bit. Let's see what happens if we make this fail by having an extra bit. Oh, I shouldn't be tweaking this. That should be. Okay. Okay, 14, 0, 0. That's still 0 if we do 0, 1. Is that? What are we getting? We're getting 10. So no, something is bogus with our with something. I don't know what it is. Why would we be getting 10 in our CRC? 10 hex, that is. No, right now it's different code for send and receive. But the interesting part is the CRC is computing correctly in at least one situation, so. When we get down here, we initialize it to 1E. Oh, unless this isn't getting triggered. I'm curious what happens if I set it to that. Let's at least see if this code is getting triggered correctly. No. This code is not properly getting triggered, because if I set this to 1, 0, there's no way it would be passing 1, 0 out. Go for the extreme. Yeah, something is, I think this code is just not getting executed for that particular branch. Okay, so let's see here. If this is a PID in, what is a PID in? Maybe we're corrupting A3 somewhere before we pass it in? No. Wait, A0, A1, A2. Oh, I'm not looking at the CRC. What is A2 here in the context of this? You guys should have caught me. I was looking at A3. A3 is the fourth parameter. The third is pending byte. Or pending word, I guess? Ooh, this is actually really helpful because we can then look and see what the last, like, 32 bits were received. Yes, yes, excellent. Oh gosh, I just love that, like, the junk remains inside the register so you can just access it and see land. Ugh. Let's take a look at this. Wait, what did I do wrong? Why did I get star star? I don't want star star, I want more. What? Okay, whatever. The last bits that were received. Okay, let's see if that lines up. So a bunch of zeros. Uh-oh. Well, that's a little weird. Does it increment? this anywhere? Okay, so oh, hold on, guys. I'm gonna have to mute the stream here. Okay. Well, I'm back. I'm not sure exactly what's going on there with this code. I think that because the header code reads the bytes in backwards, I have to look at the opposite answer or something. That, and then the kind of fun part is here, it sent it, and the CRC is wrong. But a lot of it is correct. Like, I'm kind of surprised by how far this got along. So let's see here. Let's summarize what's actually going on. Hold on, let me read the chat. I don't know if you remember, but I posted a comment in your risc-v emulator video. I said that we were working on a risc-v processor and it's finished and now it's working. Ingil is Adam. You should totally post that to Twitter and tag me, and then I can retweet it. Anyway. Sync setup. Endpoint. Sync PID 0. Get descriptor. We get the device, blah, 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 blah. So what we do is we sync and we say ACK, like, yes, we got the data. The data being like this control message that says, get the descriptor. Then the host sends us a sync, a PID in, an address and an endpoint, and O2, which I believe means it's like, it's time for you to send me data. This is the address and, I think it's endpoint, right? Yeah, the address and endpoint. Then we send back sync data 1, the length, which, wow, that's kind of annoying that it's written that way, but whatever. Oh, never mind, that's actually good. Yeah, that's fine, that's fine, that's fine. Descriptor device, okay. BCD USB, so it's USB 1.1. Device class is 0, subclass 0. That's not right. Device class, subclass 0, is that? Where is it getting that? Okay, so what actually happens is during the data, okay, so let's actually track through the code and figure out what's really happening here. So when we first connect, it sends us get descriptor, which is 6. So get descriptor right here. And then what we'll do is we will copy. Oh, interesting. So we look in the descriptor list for the index, the matching index. Index is 0. Let's take a look at our descriptor list.
think it's actually any of those. I think it's something weird. W index and W value. Okay, so that's what those are. So W value is 1 and W index is 0. So that's this one. So the device descriptor. So here we have our device descriptor. I'm not really sure why we use 0 for the subclass in device. What? Whatever. PID ACK. So we acknowledge it. It says please send us the data. So then we send DCD USB. That's that. And we send 1, 2, 3. Device subclass, blah blah blah. Then I don't really understand, why do we only send, so we send 1, 2, 3, 4, 5, 6, 7, wait, I think it's 8 bytes. I think we're sending 8 bytes. I mean, maybe that's it. Maybe it only wants 8 bytes. Oh yeah, USB low speed will only send 8 bytes at once. Durr. Okay. Okay, but the CRC is bad. I think it's because we're computing the CRC dynamically. So let's see here. What's actually going to go on? So what we actually say is DL is the descriptor list, blah, 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 pointer in and size in. So pointer in. So during the PID, so it's here. We handle the PID. Pointer in. I think all of this is valid, so we get down to here. Then we copy the pointer in plus place in into send now, and we send. Okay. And in here, in USB send data, I'm a little bit confused because what is the prototype for this function? Function is to exclude the CRC. I think that's wrong. Let's also make sure that the thing that we just dumped in there isn't, uh-oh, that's not good. I think in this case, it wants us to include the CRC. I think if it's 2, we exclude the CRC. If it's 0, we include the CRC. Are we reusing? So if it's 0, I guess. Wow, this code is gonna totally like this could be cleaned up so much in Shrinkin. Well, I'm not gonna do that on the stream, but anyway, 0 here. So send data, send now. 2 send plus 2, 0. I think we have to include the data CRC here. The data polynomial. Badger, the font name is AudioLink. It is the +2 is adding to the length, so it's 2 extra bytes. It has to send the preamble and the correct data command. The font name is AudioLink. It's from audiolink.dev. I just put the link in chat. So it's not no polynomial, it's not token poly. Okay, data polynomial, okay. A2 is our CRC. So for normal USB in the normal situation, it's like some really weird thing. It's like okay. Otherwise, it starts at 0x1f. Okay. So what we're gonna do is when we're done, we need to see if we need to send a polynomial afterwards or not. Fuck this. How about we E0 0x 0 0 y2 0 0 0. Okay. And if t0 is 0, then we don't have to send anything because it's already going to have had the poly pre-computed. Okay. So when we're done, send 0-bit. So load next byte. So if we're done sending data with the first grouping, then we have to fill in the CRC and send the CRC. Or totally random harebrained thought. Could we send 16 bits at a time, and then when we come back from the CRC,
we good night, Mobius. When we sing 16 bits at a time, and when we come back from the CRC, we may be able to just skip over trying to load any bytes or anything. Otherwise, we have to write the CRC into RAM and handle it that way, which I don't really want to do. Can we just do this? Load, what is the, it's like load, oh gosh, where is the thing? Here we go. Is there no compressed load 16-bit value? Huh. I guess there's no load byte anyway. Okay. Well, let's try load word, and let's just see if this works. This might work. So we might be able to say load word. We'll read out 16 bits at a time. Then what we'll do when we're done is if it is a CRC, like if we're done and we have a CRC, then we could just jump back to the inner loop and send last 16 bits out. I think this will be okay. And actually this will be nice. We can make the load word here compressed then, Mossler. That would be nice. Although we wouldn't want to, because then it would break alignment, but whatever. So what we want to do is we want to make sure that a 1 SLLI number of bits. Yeah, that's right. So it's still, yeah, that's correct. So we still want to bump it up by that amount. Oh boy. Good night, DIY. So instead of that, we're going to be ending by 31. So whenever that's 0, we read the next chunk, and the next chunk, and the next chunk. And in fact, we can do better than this. We can say so right here we say c.j inner loop. Let's see. Actually, wait. Maybe we can't. Hold on. Load next byte. let's hope we find somewhere else that we can save some performance in later. Because by doing it here, we can then just arbitrarily break out at any point. We don't have to have aligned things. So we can get rid of this. Ooh, but we could also do something clever here. Like we could say, well, let's just see how this goes. Okay, so and it's load next word. Okay, this is like, I feel like I'm in like a sleepless stupor, but I think this might kind of work. What we want to do is when we get here, done sending data, what we want to check, but wait, maybe we need to CRC. So what we can say is, if our polynomial is 0, so branch B, C, Q, Z, T0, so if it's equal to 0, then we could be like, no, really done sending data. Okay, so we'll do that there. Otherwise, we're going to move the CRC, which is in A2, into S0. So move S0 A2. Get ready to send out the CRC. And then we're going to load, because we need to load 16 more bits out. We're going to move A1 load immediate A1 16, load 16 more bits out, and then we can say c.j send enter loop. Otherwise, we're done and we can just abort. Okay, I think this might work. I feel like there's a lot of places for this to go wrong, but let's just see what happens. Well, that was new. I didn't expect that. I guess we don't really need to back that up anymore. Okay, let's see what happens here. Whew, gosh, 24 people. I have no idea. Okay. Oh, no, that's what I expected. Okay. EOP, or sorry, PID, hack, that thing, hit in. Well, why don't we respond to the PID in? Oh, did we already like, oh, we went off into La La Land or something. I think? I'm not really sure. is the chip crashing? Is that what's going on? Okay, let's try it. Make GDB server. One of these contains GDB. Target remote local host. Okay, it did crash. Dang it. We don't know where it crashed. Great. Wow, that's pretty broken. And yeah, we really don't know where it crashed. That's kind of lame. Maybe it's an unaligned read or write. Okay. Because we're not sending bytes anymore, we're sending words. This is going to have to remain aligned, so let's try that. No, it went off into La La Land again. Peter, I'm not sure. When did you stop watching? Yeah, you missed a lot. I can now send things back from the WCH part. Tell you what, let's just not do the CRC return and see what happens. No, it still doesn't like it. Okay, let's just send back bogus stuff. No, so something is breaking here. Something is breaking fiercely. Oh, I know what happened. Did you know what happened? Because I realized I'm an idiot. This up here, add I sp -12. I didn't balance my stack. I would bet you that that's what did it. Ah, gorgeous. Gorgeous, gorgeous, gorgeous. Probably still aren't sending the CRC. Yeah, we're not sending the CRC. But we can send the CRC now, so let's go send the CRC. How do you guys like it when I just talk to myself like this? Like some sort of rambling madman. I feel like I could be totally cogent, but it's just too, things are too weird. It's too late for that. The birds are already coming out. It's only 2 a.m. Why are the birds coming out? I don't like the tweeting birds. Okay, where's the thing I commented out for the... Done sending. No, really done sending. Load. Okay, so no, it should be able to load in the CRC back in there. LIS0 0xAA. Let's see how that goes. Doesn't it let me write in the AA? Why is it not adding AA here? Definitely don't need to do that anymore. So I'm loading that in, and we're setting A1 to be 16, so it should be able to read out 16 more values. This should totally work. Unless this is 0. But I don't think T0 should be 0 here. For a hot second there, I forgot I was streaming. That's weird. I don't know why that didn't work out. Set up ACK. Oh, maybe it was just too close to that thing. Hit in. Okay, and then we send out a bunch of data. But we're not sending out the thing that I would expect at the end here. I was expecting to see extra junk at the end. What happens if we absolutely finish that? Okay, so go. Looks like it loses its mind with the AAs that just go on for forever. Okay. So clearly we can send AA. I don't know why it's not ending though. That's a little weird. Do I have to reset it? I think I have to reset it. I think that's the issue. Alright, so yes, of course that's going to be an error packet. That makes perfect sense. Okay. But, okay, sure, let's do the thing where if A2 is 0, then we don't do this, but if A2 is not 0, then we clear it out. If branch equal to 0, oh, but it can never be 0 because I put A2 here. Whatever. If we're not using it, it doesn't matter. I'm just gonna ignore it. Let's go. Oh, come on. Branch equal to 0. Oh, it's because I wrote to A2 up here. Okay, let's try this. So my goal is just get my the packet where I send the BCD stuff to send out some junk at the end. Oh, thank goodness. It sent out some junk at the end. Now let's actually make it output the CRC. Chances are, did we get the right? Hold on, where is it? It's here. No, wait, where is it? Here, okay, so we sent this out. Wait, what? Sync, pid act, eep, pid in. So now we send descriptor type 1. Well, our code has lost its mind. not sure why this is trashed. Not sure why the CRC is wrong, but at least it's adding a CRC now. That's progress. Friday. 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 Why is it sending this back? That cannot be right. Length 10. BCD USB is all zeros. Why is it all zeros? Load word S00A0. It should work, because it should. It should read out 32 bits, LSB first. Let's go shove something in the descriptor to make it so we can tell what the heck is going on. I'm going to put AA there. Yeah, because it shouldn't be 0x10 for the length. It should be 0x18. I don't really know what is going on anymore. I hope you all are waiting for when this thing enumerates, because it could be anywhere between now and midday tomorrow. Or never, if I just give up. Get descriptor, and so we got this here. BCD USB. I don't know where it's getting a length of 10. I'm not sure why this is wrong. It's like off by 2 bytes. So that's why this here, so the 0x10 ended up here. Actually, I think I know what caused this. Okay, so I think what's going on is I think that when our loop executes, I'm not sure how to resolve this, but when this whole loop executes, what happens is, let's see, when we get to start, length right here, so that's A1. A1 is something like not an equal ordinal number of 32-bit chunks. It's something probably like, I don't know, 32 times 8 plus 16 or something, 272. Actually, let's simplify it. Let's just say 48 bits. And then what will happen is, when we transmit the first 16 bits, that's when it pops down by 2. Sorry, like, so it'll transmit 16 bits, even though it has a whole 32 bits to transmit. and then it stops, and it reads the next full word, and it starts transmitting there. So instead of like the 16 bits coming off the end, it's coming off the beginning. How do I even resolve that? I guess we could go back to sending 8 bits at once. I mean, sure, why not? That's such a cop-out, but... And then what we could actually do is something even weirder down here. A1 is 0, then we jump there. Oh yeah, and this is now, what is it down here? Oh, this is going to be even more of a mess, because we want to start computing the CRC 16 bits in. What if we try to load half words at once? So groups of load half. Oh, well, something lost its mind. Okay, so that didn't work. Oh, did I forget that I have to increment it by 2? Yeah. Not really sure why it's an error packet. Oh, weird. That is weird. Maybe bit stuffing? guess now is as good of a time as any. So what do we do when we want to bit stuff that in? Hello, David. Or as I know you, Wilmore. Let's see if we get this now. Nope, it's still bad. Still very sad. I'm not sure what's going on there. Who knows if that's where it's supposed to go? I don't. Is this not getting triggered? The font is called AudioLink. It's available at audiolink.dev. Yeah, it looks like it's not getting triggered somehow. That should be more than enough time to trigger it. So that's 4.8 microseconds, and this is 2.0. Yeah, it should be triggering. Let's try 6. Okay, well it did something. I don't know, man. This is, I guess it's close or something-ish. So we still have to figure out some way to skip the CRC for the first 2 bytes. And then start computing the CRC. I guess we could like reverse the CRC. Like start with the CRC such that when it gets to here, it'll already be FF. BFF. Let's try to at least fix this up so it's reasonable looking. Also, why is this not working? Maybe I'm not hitting the glitch filter right. It could be just too packed. Yeah. Yeah. It's not that the slew rate is low, it's that the Sele is just really bad at doing analog. Like, I mean, like, look at this. It's so buggy, it just, like, chops off the bottom half of Sig Channel 1. Ugh. Man, I don't know. Anyway, let's see here. That would be really cool. This is, oh, by the way, actually, David, while you're here, I had friends over and they tried setting up their environment, but they used the README, and I didn't know they were using the README, and the README is bad. If there's any way we can update the README to make it clear that people should be not using the README, but using the other stuff, that would be really cool. Okay, so I have this totally harebrained scheme. So what I want to do is make it so that the CRC here will just magically be correct, even though it will be including the CRC of the preamble and of data 0. And I think I have an idea as to how it can happen. I think that we can figure out what we should start the CRC at so that somehow it magically comes up with the right answer. And I know exactly how we can do it. Or do I? Maybe I know. I'm not sure. I have an idea how we can do it. Do we even get here anymore? Oh, we don't. That's right. We want to... Here. Let's add it here. Tricky junk to get to uncompute the beginning of the CRC 16s for data 0, data 1. Feels so dirty, but where's the normal CRC 16 test? I don't even care. It says it's cursed. It's fine. Interesting. So according to this, if I start my polynomial with this, when I have a data 0 packet, then it will magically come up with the right answer, because it will be FFFF after it's done the two parts of the computation that it cannot resolve. Or not resolve. The first 2 bytes of the CRC of the USB packet are not CRC. So what we want to do is to do this for data 1. I think it's data 1, right? Yeah, data 1. To do compute data 0. Okay. So let's just see if it comes up with the right answer. This is using that like cursed CRC code, which may or may not be correct. Let's see though. I mean, I'm putting a lot of faith in a lot of things right now, but we'll have to see. No, CRC is bad. Darn. Why are we changing T1 here? That's not right at all. Anyway, so that's our polynomial. Yeah, it is nice how computers can just do dumb things when we ask nicely. I don't know what's going on out there. It sounds like both sizzling and raining. Anyway, let's look. It's received 88EE instead of 7711. Oh, that's weird. Do you know what 88EE and 7711 are? I'll give you a hint. Actually, I won't give you a hint. I'll just show you how to fix it. Why? Why is that the case, though? This is super sus. What happens if instead of this, I'm really curious right now. Actually, so I'll tell you guys what I just noticed. 7711 is the binary XOR, like opposite, like not, of 88EE. They're just like the opposite things. So, yeah. Let's see, I just got a message here. So what happens if we if we switch the polynomial that we're seeking, or that we're like cheating with, to this? Oh, somebody just joined. Who is it? Oh, it's Wilmore. Hello. I can't hear you. Who wants to bet that my random selection of a polynomial target, which, I don't know, the chances of this actually being a way to do that is like basically 0. Okay, I didn't think so. That's what I expected. Okay, so you can't get around it that way. What? Why is the CRC inverted? How do I trick the polynomial into making the right answer at the end of the day? I'm sure that there's a way we can select a polynomial so that the answer at the end would be the bitwise inverse of what we're looking for. But I'm not sure how to do that. For now, for the sake of just completing this thing, how about we do the expedient thing and we say not S0 XXX to do, why do we need to not this? Yeah, that's what I'm doing, Josh. I'm just sad that math doesn't work well this way. Thank you. Yeah, sure. I'll give Friday some treats. 13FC. Well, that didn't work. Why did the not work? Oh shoot, I just gave Friday some treats, but I did it off camera. I don't want to steal it from him now. I'm sorry. Well, DIY, I promise I gave him some treats.
Um. I can't just give Friday an unlimited number of treats. I don't know. Why is the CRC still wrong? Let's try this again. Friday really wants more attention and or treats. Can we at least get back to where we were? No, we've broken something. What have we broken? That's the old poly. EV7. What happened? We had the right polynomial inverted. Just okay, let's see what happens if I undo. Please be, okay, 88 EE. Okay. Let's change exactly one thing, because maybe it'll be okay. Let's only change exactly the polynomial that we're, or the intermediate that we're looking for. Okay, so no, even just switching that's not going to save us. Okay, let's switch that back, and then let's also, instead of move, we're going to not it, and we're going to see what happens. Okay. Hey, CRC, okay. Okay, so I'm gonna go commit this right now. Got a data 1 CRC, okay. Git push. Okay, now let's see what happened next. So the host then says pidac, and then hit in. is a good little boy. What is he trying to tell me? What's wrong, Friday? He wants to be a beard? Is that it? Anyway, so we say sync pid in blah blah blah, okay. Sync pid in blah 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 blah. And then the host resets us. What the heck? Okay, let's look here. Oh snap. Something went really wrong. Like disastrously wrong. Okay. What I mean is, we successfully sent a message back, but then the host sent us sync and then a PIDAC. Can you guys hear him? So my concern is that something happens so that I don't know who's sending this PID in. I think it's the host that sends us that. Is it? PID setup. PID data. PIDAC. PID in. We send the thing. It acts. Then it sends a PID in, but for some reason we ain't getting it. Why would we go off into the weeds on the PIDAC? Go off into the weeds there. And then I think once we do, we're like crashed basically. How about this? How about we run in the debugger again, because that worked well last time. Make GDB server, do this thing. Okay, we run for a little bit, it figures something out. I don't know, maybe it's figuring something out. Who knows? It's still going though, for some reason. Maybe I should have like... it's like the lights are on, but no one's home. Yeah, it's still. Yeah, it's like the interrupt just isn't getting fired anymore. Why? Why would that be? Hmm. I am entirely too tired to be doing this. How many hours? We're up to 5 hours and 23 minutes. I'm gonna call it in 15 minutes. Unless like there's some major major thing. You're a good boy, Friday. Okay, back to the work. Friday is a very good boy, aren't you, Friday? Aren't you a good boy? Friday, Friday, you're a good boy. Of course, unlike dogs, Friday couldn't care less if he was a good or bad boy. I often wonder if he's embarrassed that he is a good boy. What in the world could be going on? Because we won't be in an interrupt. Because we're in the main loop. Did something maybe... Is there another return out of here somehow? No, it looks like this is the only return out. So what could be going wrong? You know, I'm just going to try capturing and doing this again. Well, that didn't work. Okay, well, let's just try make clean all. Guess it has already bit the dirt. Let's try from the clean one. Yeah, something goes really awry here. After the ack, it doesn't recover. It's just toast. Handle ack. I'm not sure what could go wrong here. Wait, do we not have code for handle ack? That's weird. I guess we don't have. Do we not handle ACK? We don't. So we're looking at bit 4, branch equal to 0. So it's this. This would be inverted. Otherwise, oh, I see. Branch equal to 0 goes here. Okay. Because it's actually the inversion of this. And then if it's a setup packet, wait, branch equal to 4. 0? And oh, 4, so it would be this bit. Okay. So it's these. If it's 0, then it's a data packet, okay, because it's inverted. That. ACK, NACK, or no, setup out in. Setup out in, so it's 0 there. What we want is to handle an ACK. Does host, I guess the host has to send an ACK. So this would be the same as data. Data 0, 0. Okay, this is annoying because it's inverted, but is it like, I think it's inverted and backwards. So 1 1 or 1 0 1 1 is setup. Setup is 1 1 0 1. So no, it's just mirrored. Okay, so 0 1 0 0 0 1. Wait. Oh no, we handle the ACK up there. Did handle ACK. If it's 1, then we handle ACK. Oh no. Oh. Oh, I hope that doesn't break anything. So that's why whenever we got sent an ACK packet, we would just implode, which, yeah, I mean that's just like a bug. Okay. Well, at least now we're not imploding anymore. That's a good thing. Okay. So ACK in, so we've already sent this. We have to send a few more bytes of data. So let's see, let's look at USB config. So now we still have to send 1, 2, 3, 4, 5, 6, 7, 10 more bytes of data. So we send data 0, which, yeah, like, I get it. It's... Oh, no, it is. It's ID vendor. Okay. Okay. Okay, we're getting somewhere. We probably want to change the ID rev and all that from ESP USB. Manufacturer is 1, product is 2. Ah, and now we need to be able to send data 1 or data 0 for data 1. We need to do the same thing for the other, for data 0. So data 0 is 1 0 0 0 0 0 1 1. This will be for data 0. Oh, duh, I need to recompile this. C. Uh-oh, no, 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 we gotta do this. Okay. D6, D7. It's time to handle the to-do from above. Hmm. Is there like a branch equal to in risc-v? Branch equal immediate or something? I don't think so. Sub IA3, comma, oh, we want to and IA3 0xFF, or F, 0xF, because we only care about the bottom few bits. Data 0. I think it's like weird because it's easier to deal with the LSBs, even though then it's like logically flipped around. Or not. Nope. Data 0. I guess it's flipped around another way. I don't know. We'll just if you flip things around enough times, eventually you get the right answer. 0 1 1. If these are equal, then it'll be data 1. B, use the A3 is data 1. No, data 0 is data 0.
let's take a look at some of this data. Okay, so that CRC is okay. CRC bad. You know, let's just see if that's just the thing. Maybe it is. C09E. Somehow I'm not successfully detecting this. So it looks like data 0 is 1100 in the low bits. Starting from the low bit first. So if I read from this, and I mask off the low bits, I add negative 0011. It should be 0 if bad. And it should be, I should preload A2. Friday. Whoa, no do. No steppy on keyboard while Charles E type. Why is it the same? Why is this not working right? One zero zero. We mask off the beginning. If that's it, we use this. I mean, whatever. Let's just shove that in there and make sure that we get a different answer. So C09E is the price to beat. Oh, I should have been looking at the other thing. C698. Okay, now let's see if we do that, if we get a different answer than C698. Also, let's make sure the first one is C698. No, it's not. Okay. So, we want to make sure that it's different than C698. Let's see, what is it? It is still C698. Why is it? Okay, whatever. Fine, let's just try this. C69E is what should be changing. I keep getting that backwards now. C09E should be changing. If we've successfully found a data 0 packet, then this should no longer be C09E. is it still C09E? Why? Friday, you are a little rambunctious maniac. No, I'm using the not in both cases, but what I'm saying is, if it's data 0, it should at least be different. Let's just test this, BNEZ, and make sure that we're not, like, completely insane. So C09E is the price to beat. Holy cow, I don't even... Okay, well, that's not gonna work. Okay, what am I doing wrong here? I'm reading the second word. Oh, wait, no, what am I doing? That's the thing I want to match. Okay, let's try this. Chance of getting it right is almost 0, but... Oh, also I need to switch this back to branch... No, that is branch equal to 0. CRC okay. Why? What? Oh, CRC okay. 7711. Okay. CRC okay. 6 blah blah blah. So hopefully over here, PID in data 1. Okay, so this is the rest of it. And the CRC is okay. And the host is actus. I mean, in spite of like this whole bit stuff looking just like absolute wonky, which we should fix. Let me at least tweak it to make it a little better and a little less crazily offensive. Why is the line going into reset, I wonder? Is the kernel going to tell me something about this? Okay, let's just try this again, and let's just see what happens. Unable to read config index 0 descriptor, unable to read config index 0 descriptor, unable to read config index 0 descriptor. Okay, well, let's try to figure out why from this. Oh, yeah, sorry about that. This is the D message. I didn't realize that was off screen at the moment. But yeah, it's this. Let's try it. Oh, that's lucky. Look at that. We got it 9999 for the wait, 129999. What's up with the 9999s? That's weird. Huh. I wonder if there's something to that. Why is it ending in 9999? Anyway, that's weird. So let's see here. So ID product, BCD device, manufacturer, product, CRC OK, host ACK, PID in, data 1, serial number, number configurations, CRC OK, PID ACK, PID out. Oh, what is PID out? I don't remember what PID out means. It means something. That's weird. Oh, PID data 1. There's no data. I don't know why in the world would the host send me this, but whatever. I guess we just ACK it for reasons. And then we go into reset. And then something happens over here. What happens over here? Makes the request. We ACK it. Hit in. Hit data 1. Oh, and we're now like just empty. Why do we send an empty thing here? Maybe it's asking for a different descriptor? What is it asking for? Oh, set address. Oh, that's cool. Okay, so it's saying set address, value 14. So our new address is 14 on bus. Okay. So, is this really not working? I mean, it's really not working. Hit in, address 0, CRC OK. But what does it expect from us? Like, when it sends set address, what do we do? We just accept it, I guess? What? Are we supposed to send something back? Does this have anything on it? USB functions? here it is. Set address, W index, value is device address. Data, none. Okay. Do we just accept it and roll on with our lives? I guess so. Sure. Okay, fine. Then I mean, I guess that's it, right? By the way, I see that you mentioned out token is followed immediately by data X frame. Where was that? I don't even remember where it was anymore. Okay, well, anyway, so like I guess things are okay there, but then like over here is where like important something happens. Okay, get descriptor, W value, W length, okay. I guess it somehow remembered that our length was 12 hex, okay. PID in, so we send the descriptor. DCDs, yeah, so we're device descriptor. It sends an ACK, and it sends a PID in, and then we're going to send the rest of our descriptor, well, most of our descriptor, PID ACK, PID in. Then we send the rest of our descriptor back, the host ACKs it, PID out, data 1, and it's just nothing, it's just like an empty packet, I guess. Is that, maybe that's not right. And then we ACK it. Oh, I see, PID out. So it just sends us like nothing, and then we ACK it. Okay, sure, whatever. PID setup, address. Okay. 0, request type is 80. Get descriptor. W value is 0x200. Okay, so let's just see what that is. 0x200. Okay, so that's the configuration descriptor. Let's take a peek at it. Oh, this is that terrifying thing. Sure, it's like a mouse keyboard octopus. I don't know, maybe that's the problem, who knows. Oh no, I zoomed out and I lost it. Okay, got descriptor. Oh no, I lost the whole thing. Whatever, that's so fast. Okay. Value 1, okay. Here, what is this one? Value 200. So now it's requesting this monstrous descriptor. PID in, and then we start sending stuff. So descriptor type 2. Total length is 38. Or 3B. Interfaces is 2, configuration value 1, blah blah blah, CRC okay, sync PIDAC, okay, PID in, so send us more data, uh-oh, error packet, what's wrong here, why no go, what's wrong? What are we screwing up? hoping for a data 0 here, I think. Zero, 0, 1, 0. What? No, that is wrong. 0, 0, 1, 0. 0, 1, 1, 0, 0. Yeah, this is a completely broken packet. Why would the data be so jank? So we have a preamble, that's successful, but then we send 0, 0, 1, 0. 0, 1, 1, 0. That doesn't make any sense. It's just garbage. Let's see how many bytes it is. It's 1 byte. 2 bytes. 3 bytes. 4 bytes. How could this get corrupted? I guess if it's not aligned, it could get it corrupted. But like, it's gotta be aligned. Oh gosh. Come on. It's fine. I know what I'm doing. You can just treat things as pointer. Oh my gosh. Just let me convert this to a pointer. I mean an integer. Please. I do not need your SAS compiler. Yeah, it's not gonna get hit. It's doing the right thing. so well, that kind of makes sense. It's going to be 4B all the time. If it's data 1, so okay. Oh, okay, it's also going to be, this is stupid. I want to know why code inside Is this getting hit? No, it's not getting hit. What in the world are we sending it? Why this packet? Where is this coming from? So we send data 1, which makes sense. Is it that it's like the wrong size? Like, is it that it's like sending like 1 byte of data? So like what I notice is that it says here B length is 9. And so maybe that's somehow confusing things later. I don't see how. Come on, we're so close. This could totally happen today. I think I want to add some, like, I don't know, fuzzing, debugging. I want to at least like bzz or whatever so I can know Friday. No. It's currently 4 a.m. here. Oh gosh. Setting Tim1 CNT to 0. What I'm going to do here is I'm going to make it so that I want to at least make sure Tim1 CNT is 0. I want to make sure that we're actually getting in the function I think we are. So let's try running this. So we should be able to see when we're sending a reply packet. Or did I do something wrong? When we're sending a reply packet, why did that not work? This should be triggering. Handle in. Oh wait, I think this is it right here. Okay. So I twiddle a GPIO line so that I can like tell what's going on, basically. That's concerning. That's a long lead time. You really want to, like, answer the host as fast as possible. At any rate, let's just peek here. So error packet, let's see. Good, okay, so yes, that is in fact triggering, okay. So now let's see, is it a data 0 packet that is somehow getting corrupted? Here's our error packet. Ooh, hello, friend. Now let's make sure it doesn't show up for a data 1 packet. Yes, it does not show up for a data 1 packet. So it is a data 0 packet that somehow things are getting bonked with. What could happen in a data 0 packet that things would be sad? Okay, let's figure out, is it this one here? I think it's this code here. Let's look for those sweet, sweet error packets. Okay. So yes, it is in fact this code here that things are starting to break down in. Spectro, the way I learned it was by trying to solve a problem until I didn't know how to solve it, and then I just kept working until I learned how to solve it, and then I found another problem, and I just kept working. Most of what I've learned has just been out of being a hobbyist in this. I learned a lot from like professional career in college, but I think you learn the most when you like sacrifice TV and things like that to be able to just learn and grow. It's important to grow. So in here, so now I know it's this. Yes, curiosity and persistence. Like, if you know that there's something hiding, it's nice. Is line 218 correct? What is advance in? Yes, advance in is correct, because the idea is that you wanted to advance pointer plus place, or not pointer plus place in. You would want it to advance along that many bytes, because that's how many data bytes that you're sending. Man, this is weird. What is at to send plus 2? To send plus 2 is the amount of data that we're going to send plus the 2-byte header, which is the preamble and data 0. This logic is so bad. Pretty sure we should just go to like c.j done data here. this behaves. Let's also make sure we didn't break anything. No, it looks like it's still there. No, the preamble is included in the main buffer in this case. I think that that was a really silly design choice by me a long time ago. I don't know what I was thinking, but I included the preamble in the buffer. I mean, it does make it so that there's going to be less code size, but it's just such a weird decision. I don't know what I was thinking. Okay. Well, EOP, good. And then we have this flaming nightmare. Why not just, why do we not advance to by 2 send plus 1? Oh, okay, so what actually is happening is our descriptors live in data here, and what we're doing is we're copying the descriptors out of that and into this temporary storage buffer that has junk in the front, which is the preamble, and then after the preamble and data 1 or data 0, depending on which it is, it has that payload, and then we just say, please just send the whole thing. No, I haven't slept yet. I feel like we are within shooting distance of having this enumerate, and then I can finally call this entire live stream thing done, and I can just stop streaming, and I can make the USB stack nice, but I have to figure out what the heck is going on here. It's so close. We're so very close. Basically, like, I get the device descriptor across, I get part of the configuration descriptor across, and then my USB stack just starts sending these weird error packets, which I just don't know where they're coming from. I don't know what's causing it. I don't know. 1, 2, 3, 4. No, I have not tried a different host, but it's my device that's the one at fault. I'm the one who is sending the error packet. I'm the one who, like, I have done something wrong. I don't know what it is, but I am the one who, for some reason, I am sending, let me find it again, this turd. What is this turd? Why is this turd? I don't know, but this is the turd. The preamble is correct, but I send 0010, 0110, and that is complete and total nonsense. I still don't get why advanced to send shouldn't be advanced to send plus 2, because we're only sending 2 send bytes. We just throw on an extra 2 bytes at the beginning for the preamble and the data type. They're not useful data. They're not the data that we're sending, they're just protocol artifacts. And also, I'm not annoyed. I'm just tired. Like, this is perfectly good. Please continue to chat. This is wonderful. I don't know, man. but yeah, no, keep going with that. I don't think that that's correct. Oh yeah, Manny, there's 1,000 things that could make this cleaner. But I just want to get this to go so that I can do all of that cleanup, like, on my own, alone, and without 26 people watching. What I want to do is give you guys the satisfaction of watching the device enumerate in my computer. I really want to give you guys that. I am so confused here. Friday. Friday. Get down. Down. Get down, Friday. You have to get down. Joshua Ashton, I don't understand the question. Here, let me submit the code. I think if update mid commit update midstream. You might want to just check out the code as it is, and then you can take a gander. But I think that the logic is correct. I don't think it should be 2send plus 2 because we don't want to iterate over. Like, we don't want to drop the 2 bytes off the end of, like, when we're transferring the... Friday. This cat is insane right now. Yes. Just send this twice here. Also, this seems so strange. Why in the world does my Linux box, like, shut down the bus for some odd milliseconds? It's a little after, what is it, 4:30 a.m.? So Friday is, like, going nuts. Or it's a little before 4:30 a.m. And to be clear, I think that this design was really bad. I don't know what I was thinking when I wrote that like 10 years ago or whenever it was. Oh, maybe it is the birds chirping that do it. So like I am gonna like rework a lot of this, but we're so close to getting something that can enumerate, and I just don't understand where the error is coming from. This is, that's the 2 beep beep, and then it's a data 0, but this is not data 0. This is like some kind of weird garbage. Maybe, I don't know, this would be interesting. What if, and I A3 A01 E let's try that, because that'll tell us if there's like an alignment issue. It's not going to be the world's slowest hid device. It's low speed, but like AVRs will do that. It's not terribly hard if you like don't screw things up like I am. I mean, I am, but I really don't get it. Cause like here I'm saying if it's not aligned, then like do it. So it's clearly still aligned. Otherwise, I think it would actually crash. But I don't understand how this is possible because 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 0. Wait, so what is this? This is... $60, 100 decimal. D. I'm gonna just make sure that we're not missing something obvious, like num interfaces, blah blah blah. Like, let's make sure that this isn't like the next byte in the descriptor table or something, because that would be just silly. Blah blah blah. 0x80. Oh no. What in the world? Okay, let me guess. The byte after it's going to be 9. No, the byte after it is not 9. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 16. Stop there. And so the next one is 0. It's 2. I started doing this backwards, darn it. Okay, let's try it from the back. So it reads 806402, and then so So we've already read the byte and we know it's right. How is it wrong? Oh no, this is the bug that bit me a little while ago, in that what'll happen is it'll read out the first 8 bits because it's an odd number of bytes that we have to work with. Then it's going to get to 0, and then it's going to be like, oh, but we still have, oh gosh, this is awful. I don't want to work on this. The problem is that, okay, so here's what the deal is. What happens is, down somewhere here, load half right here. So it reads the first byte, but because the bottom, well, can we get around this somehow? So alright, it reads the first byte, but it sees that there's like, so say it's like 12 bytes left. It reads the first, or not 12, 3 bytes left. Reads the bottom 8, and now there's 2 bytes left, and 2 bytes is divisible by 16, so it goes back and it reads it reads the next thing, and when it reads the next thing, it blows away. Yeah, so this is so annoying. The way around this could be to just load byte, and then we do extra logic down here in the CRC, where somehow we can try to convey let's see, branch equal to 0. But the idea though that I want to do is I want to be able to, if we do it this way, we have to split the CRC into 2 separate transfers. I think that that's okay. SRLI T0 8 X T0 So we actually want to send, I don't even know if the CRC is set. Let's just try, just try something and see how this goes. So we're going to the goal is split up the CRC into individual bytes. SLRI, SLRI, A2, 8. And let's just see how this goes. Mistyped it because it's SRLI, because I've done that every time so far. But I also get that wrong. sure. Because if T0 is 0, it should just skip. Yeah. Okay, what am I messing up this time? Load byte, add I by 1. Oh yeah, because we need to only look at, yeah, because we're only sending one byte at once. Every single byte we have to go back and read another byte. Okay. Okay, good. Yep. Oh, bad CRC. Oh, this is going to be a little weird because it's going to be. Okay, let's see here. What? 1108 versus 1017. What? I thought it would be like switched around or something. This is data 1. It should be fine. I somehow break this code up here. I don't think so. I mean, maybe I did. Add CRC received 1108 and Calca's 1017. And let's see here, does this look right? Device, BCD, protocol. I don't know, it looks pretty good to me. You know, except for the glaring CRC error. Oh. No, it should still be right, because 'cause it should still be processing through each one of these, and then the answer should still be the same. Just confused by that. We could just do a really cursed thing. Let's do the really cursed thing. I will fix it later. I'll explain the really cursed thing in a moment. Oh, it won't work though. Will it? Oh, I think it will. We'll find out if the really cursed thing works. The really cursed thing is, if we're going to send, if toSend is odd, then what we're actually going to do is this really terrible thing. Is we're going to, instead of doing this, we're going to say +3, and we're going to say send now of 2 is equal to send now of 1. Yeah, that's cursed. Super tricky. If we are odd, it will accidentally skip the second byte. Okay, sure, let's give this a shot. CRC is okay. CRC okay. CRC okay. Okay, so we're starting to get some CRC okays. We do whatever the heck the weird reset thing is. I really don't know what's up with that. Oh, Nelly. Whoa, Nelly. Oh my gosh. It did it. It did it. Oh my gosh. Okay, Scotch, I'll give Friday a few treats. Oh my gosh, it's finally over. This torture is over. Here you go, Friday. Do it for the camera. That's it. It's a wrap. Well, it's not a wrap. It's the start. You were here, BitLooney. We're gonna do it. It's gonna work. I'm gonna go shove some resistors on a bunch of these boards. I'll mail them out to some people. Wait, start another what? I don't want to do any more. I mean, I guess I will to fix it, but yeah. So what we have is we have new low-speed device found. ID vendor is blah 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 blah, and it identifies as an RV003 USB. And actually, the really fun part is this is the interrupt thing that happens every time. And right now we're just knacking it because we don't have any data. But Oh man, let's do something. Okay, let's just push it like another few inches. I'm gonna make it so. Knack. Where's the knack? Control message aren't if endpoints. Point is 0. Oh, I see. To send. E arrow send? To send. I don't really remember how ESP USB. Let's see how ESP USB works. User main. Oh yeah. Good point. Let's commit this before I break something. It works. Or actually, let's go. It's alive. Okay, it's pushed. Okay. Now let's see. How do we actually like send data? I don't really want to handle custom control. What we're going to do though in the end is this is going to be able to flash itself over USB like an Arduino. This is a self USBing Arduino, or will be someday. What I want to do is, oh, I see. I can send endpoint stuff. So sure, let's do keyboard. Key mod, key BT. I don't really know what those do, but I'm sure we'll figure something out. Do we even have those endpoints? Let's get rid of printf too, because we really don't need that. Key mod 0xa14, I don't know, 0x80. I'm just gonna guess at some of this stuff. Wait, my EP2, what is this garbage? Oh, I see. Ugh. I can't remember what key BT means, but I don't know, who knows, maybe this will just work. I mean, like, if I get it to compile, maybe it'll just work. Holy cow, GCC is on the money today. Oh. Okay, well, let's not do that right yet. Oh, come on. Is it broken? No, it is fine. It's also possible that it could be flaky. Like, we haven't, like, really done a good job at this yet. Oh yeah, good point. I can do dmessage -w. Okay, so it enumerated there. Let's add some of this stuff back in. Disconnect, reconnect. Okay, let's add a little bit more of the stuff back in. Disconnect now. Reconnect. Okay, so that worked. I really wish I documented what in the world my EP2 was. I think that's keyboard. I wish I could use this tool worth anything, but I'm really bad at the new Git browsing thing. I think keymod is supposed to be 0. Let's try that. Let's see, pid in address endpoint 1 NAC, pid in address 2 NAC. That's sad. Let's get rid of these two and see what happens if we just scream. No, we can't scream. That won't work. I think one of the issues is that maybe it's just that it wakes up too much, or like the, well, anyway. Let's see, do any of these not? Back. Knack. Okay, well let's, maybe if we add like a big delay at startup, it'll be okay. 1 second? I don't know. No, it did not like that. 2 seconds? Did not like that. Oh, what the heck? Whatever. So now we knack. That's not good. Why are we knacking? I know that there's data. Knack. Okay, so something's just hokey. Bye, Bitloony. I just love it if when we could just like make it like print something like out to the screen. That would be so cool.
Hey Charles,
Ah!
just a quick question.
Oh, wow.
So it's sorry. Sorry. Is my mic hot or something?
No, I just wasn't expecting to hear a person's voice.
Oh, sorry about
And
that.
Josh Ashton, you can't do ACM, you can't do serial over low speed USB. That's why, that's another reason why I want to do everything with the HID messages, both because it works on Windows without anything, and on Linux it's a lot easier if you add that weird plug dev thing. And everything is framed. It just means no serial, because I hate serial. Because it's not framed and you're running on a protocol that has framing, it's a complete waste of everybody's time. Like, we should not be using serial over USB. Okay, go for it, Sammy.
Okay, so the knack thing, is that the host not acknowledging, or is that us not acknowledging?
No. Okay, so here, I'll point it out. So what happens is the host says PID in, it gives me an endpoint 1 and my address, and it says, hey, like, do you have anything for me on endpoint 1? And I'm like, nope, I don't have anything for endpoint 1. And it's like, okay, do you have anything for endpoint 2? And I'm like, nope, I don't have anything for endpoint 2. And I don't know why I don't have anything for endpoint 2, because I clearly am saying send. Send is set there. I have a size. I have a pointer to my data. Like, it should be fine. The actual knacking is happening here. Like, if toSend is 0,
Oh yeah, I have the like 5 second stream delay. Okay, yeah, there. Now I see it.
but like, wait, could this result? No, neither of those can result in knacking, so it has to be here. So if not send, or not pointer in, or pointer in is equal to, wait, what? Send empty buffer. Oh, well, that's weird. But the point is, I don't think to send should be 0. Unless, what is to send? Where does that come from? Oh, size in minus place in. Maybe that is the issue. Oh, maybe. Sure, let's go put this here too. Okay. Also, Sam, I honestly don't hate CDC. I'm just really bitter that up until kernel 3.14 or something, you were allowed to be, like, you were allowed to say, I am a CDC device, even though, that was Friday, that was not the keyboard. You could say I'm a CDC device, even though you were a low-speed MIDI, or I'm a MIDI, low-speed USB, or I'm a MIDI device, even though it was a low-speed USB. But then, like, the kernel just was like, no, that's not cool, it doesn't follow the spec, we're going to close it. I really don't like people who follow specs. Like, I would rather just, like, fix the problems that people who wrote the specs caused, instead of just treat it like gospel. I'm not really sure. I am, anyway. So, now I'm doing place in, size of my EP2, pointer. Do I have to update that too, I guess? Let's just update everything. Okay. Low speed absolutely can be supported by WinUSB, thankfully. Absolutely no problems with that. 100% works. Actually, what's even better is HID API. You don't even need WinUSB to talk to the HID device. You can put in special things in your descriptor, and it it doesn't even need like a WinUSB driver. It itself can be whatever it wants to be, and you're allowed to send control messages to it, like nice framed, like, you know, send this message with this many bytes to this device, and Windows will do it for you, even if you're just a user. If you put into the descriptor header inside the USB descriptor that like you accept this from users, then Windows will obey it and let you send it messages without any like without complaining, basically. Let's at least make sure that this is actually getting triggered. Oh, actually, I want to just go from here. Okay, let's see here. So we have that, and then we do get triggered right here. So that is a NAC, so that means that it is this code that is being executed. So what I could do here is I could say if toSend is 0, then we'll trigger it. So is toSend 0? I don't know. Wait, I'm sorry. I just realized Joshua Ashton said what to something, but I can't remember what Joshua Ashton said that to me for. I'm very tired. So toSend is in fact 0. So if eSend and eArrow pointer in, size in, place in. So send in, pointer in, size, send, place, pointer, size. They're all valid. They're all valid. Send. Let's see if we can figure out which one of these it's the problem of. So is it either of these? Oh yeah. That's right. The CDC thing. I think I explained, right, that it was just that I was just bitter about it. That like I wish that you could do CDC over low speed USB, but because somebody on some standards committee was like, why would anyone do that? Maybe because I want to. Like, I don't know. So the answer is this is now false. So maybe this is it. Let's try this. That's interesting. So what's going on right now is I just determined that eArrow send is false. Let me just like confirm by going the other way. Which if? I don't want curly braces on this if. Okay, yeah, so both of these say send is false. Wonder what's going on here. E2 send should be true. Sam E, I'm not sure which if statement you were talking about. Was it this one? just realized this is terrifying. There's a bug in ESP USB where, anyway. No, I really believe in Pastel's law, and unfortunately there are people in the world who think that I'm wrong about Pastel's law. Oh, never mind. This is actually safe. NP is... So how many endpoints are there? 3. Okay, yeah, that's fine. Yeah, I have 3 endpoints. I have the control endpoint, I have a keyboard, and I have a mouse. Oh, I'm not sure why it took that much convincing, but I mean, I guess eventually it accepted it. Okay, endpoint 2, here's the endpoint 2 data. Everything is a 0. What is going on? Why is this code, like, not getting called? I guess I don't really care at this point. I'm just gonna go shove some data in here and be happy. Okay, 00800000. Oh, 44. Good. Okay, so this is kind of working. I just can't for the life of me remember how this works. Dev input event 29, I guess. I don't know. 5, 6. Dev input mouse 4. What the heck interface is this? So it's either mouse 4, event 10, event, there's a lot of events. Event 9, event 30, 31, event 256 and 257. Input event graphics, pipe, text dump, FC. Okay, maybe 257? Oh, that's not, I don't think that's this device, is it? Oh, I'll be darned, it is. What in the world? Oh, those are the timestamps of the events. Okay. Well, that's weird. Okay, well, oh yeah, it looks like the mic got switched. At any rate, I don't know. Things are kind of working. I'm gonna undo all that garbage I just put in the thing. Gotta make sure it still works. Looks like it works. We have a USB device. End of stream 5. Thank you everybody for coming out. It's done. I'm going to work on this a little bit over the next week or so. I think that I'll get in a pretty good place. Maybe I'll have a bootloader or something like that for it. Yeah. I'm pretty happy. Hit push. Okay, well, hopefully no more streams for a very long time. Have a great day, Saturday, weekend. Everything worked out. Thank you for joining. Goodbye.